Hello and welcome to this course on Spring Core. So this is an introductory Spring course. It covers core Spring concepts. In this course, we'll explain the concepts and we'll have live coding. Welcome to this course. Who is this course for? So this course is for anyone who is interested to learn Spring, particularly Spring core concepts. Then any Java developer who wants to enhance their skill set on Spring. And this course is also a quick refresher for experienced Spring developers. What all we need to follow along with this course: Java knowledge, as Spring is a Java-based framework, so a basic understanding of Java is required. So you must be familiar with the concept of class, object-oriented programming, inheritance, Java collections, and so on. You should also know about Apache Maven. So Apache Maven is a dependency management tool. So in this project, we will be managing our Spring dependencies through Apache Maven. So we do not need too much understanding about Maven. So the basic understanding of Maven, like what is a POM file, what is dependency, should be fine. Basic understanding of XML. So Spring Bean configuration files can be written in XML. So a basic understanding of XML is required. So we do not expect too much of understanding of XML. So basic understanding such as what is a XML file, what are different XML tags, the root tag and attributes should be fine. What all components we need in this project? So we definitely need JDK. So Java we would be requiring in order to write our code. We need Apache Maven. We need Spring. We need one IDE, Integrated Development Environment. So we will be using two IDEs throughout this course. The first half of this course we will be using Spring Tool Suite, and in the second half of this course we will be using IntelliJ IDEA. So we will be using Spring Tool Suite because STS provides support for XML configuration files, so it will be pretty handy. So what all components we are going to cover in this course? In this starting module, we are providing the introduction, and then in the next module we will be setting up our development environment. Following to that, we will be introducing Spring core concepts. Next we will be doing XML based configuration. So we will be writing our beans and we will be instantiating the container, Spring IOC container, and we will try to access our POJOs and all those things. In module 5, we will be auto-wearing beans. We will be seeing how Spring can automatically wear the beans. Then in the next module, we will be seeing Java-based configuration. Following to that, we will be loading external files. Then in module 8, we will learn about Spring expression language, which is Spell. We will then discuss about Spring AOP. Spring AOP is another way of programming. AOP stands for aspect oriented programming. So we are familiar with OOP. OOP is object oriented programming. AOP is aspect oriented programming. In OOP we deal with object and object communications. In AOP we generally deal with aspect. So we'll see more about AOP in this module, Spring AOP. Then we'll learn about Spring Task Executor, different type of executors which Spring provides. Then we'll deal with handling events, how beans can communicate with each other through different type of events. And then in the last module, we will be concluding this course. What all we won't be covering in this course? We will not cover core Java. Since this is a Spring course and Spring is a Java framework, we expect you to know core Java. We will not cover Maven because in this project we will be using Maven only to manage our dependency. We do not need too much of understanding of Maven. Will not cover Spring Boot. Will also not cover any other Spring modules such as Spring MVC, Spring JDBC, transaction, JMS, RJP, and all those things. So in this module, we introduce you to this course. We provide the tools we require in order to follow along with this course. And then we discuss who is this course intended to. Then we provided a brief walkthrough about the different modules. And then we talked about what all components we won't be covering in this course. Thank you for watching. I'll see you in the next module. Welcome to module 2 of Spring course series. In this module, we'll be setting up our development environment. So as part of environment setup, we will be doing installing Java. We will be installing Spring Tool Suite, and then we will be installing IntelliJ IDEA. So let's get started. In this lecture, we will be installing Java. So head over to the browser. So currently I am in Oracle website page. Here go down and look for Java version. So we have Java SC Development Kit JDK 12 and download JDK 12 now. So as of this recording, JDK 12 is available and we are going to use JDK 12. Though in this course we need JDK 7 and above, but since JDK 12 is available, let's download the latest version. So once we go to this index page, here we have all the versions: Java SC 12, Java SC 11, Java SC 8. Head over to Java Platform Standard Edition 12. And then we have download option for all the versions: Java SC 12, Java SC 11. Java SC 11 is the long-term support version. But as I said, we are not interested about specific Java version. We just need JDK 1.7 and above. So that should be fine. Let's go to Java 12. In this page, we have the download option. So we have for Java for Linux, Java for Mac OS, and Java for Windows. Before downloading, we have to accept the license agreement. And now we can download based on our operating system. In this course, we are following with Windows. So most likely we need to download the Windows version. Already I have downloaded Java and installed in my system, so I'm going to skip this step. Thank you. In this video, we are going to install Spring Tool Suite. So Spring Tool Suite is an Eclipse-based IDE. If you are a Java programmer, you definitely heard of Eclipse. So Eclipse is the IDE for Java-based coding. So Spring Tool Suite is based on Eclipse. It is customized for Spring development. So Spring team has taken Eclipse as base, and then it is heavily customized for Spring. So different Spring nature is added, and it is mainly for Spring. It is freely downloadable from this Spring website. It is available for Windows, Mac OS, and Linux. Let's head over to spring.io website to download Spring Tool Suite. So currently I am in spring.io website. Here we have the option to download Spring. We can download Spring STS for Linux, we can download Spring STS for Windows, and we can download Spring STS for Mac OS. So based on your operating system, you can download the version. Since I have already downloaded this, I'll skip this download part. So I have already downloaded Spring Tool Suite and I have extracted it. So you can follow the same download and then extract. Once it is extracted, head over to the Spring Tool Suite version. So current version as of this recording is 4.3.1. We will be using this version. And then let's head over to Spring Tool Suite 4 and open this tool. So initially it will ask to select a workspace. So by default, for me this workspace is selected. I'll continue with it. And then we are launching Spring Tool Suite. Again, it will take a while to initialize the workspace. So here is the Spring Tool Suite console. Let's just go through it. So in the left side, we have Package Explorer. So all our project and related information will be here. This is the area where we have where we'll be having all our Java files as well as XML files and other configuration files. This part is for Spring Boot. So anyway, we are not using Spring Boot in this course, so this part will be of no use for us. This is the area where it actually shows all those things. If your project is having any problem, it will be displayed here. We can read our Java doc at this place, and then declarations, and then console. So console will be useful, will be coming here again. So all our outputs will be shown here. And the progress tab. In the progress, we'll have a different progress information, such as, for example, once we build the application, or once we run our program, or for example, once Maven is building or the class project is getting built, all those progress information will be shown here. Now here is one catch. I have downloaded Spring Tool Suite 4, and as I said earlier, we are using Spring Tool Suite in this course, first part of this course, because in the first part we will be dealing with XML based configuration. So in XML based configuration, we'll be writing our Spring definition file, which is in XML, and then we'll be defining different beans and all those. So initially Spring had good support for the XML files. You can directly create the XML file and you can select the namespaces and all those stuff. But as I found out, Spring Tool Suite 4 has actually removed that support, XML support, which you can actually find in this GitHub issues. So XML config support in Spring STS, this version 4. So they have reported an issue. So we have found one shortcut. Spring actually provides a plugin. Normally Spring Tool Suite 3, which was the previous version, was having this support. So we can actually have that STS3 plugin, and then we can still get access to that particular XML configuration and XML nature. So Eclipse Marketplace, we have all those plugins and things here. We can download different type of plugins. So our STS3 plugin will also be available here. It takes some time to initialize, so it got initialized currently. Let's search for STS3. So STS3, as I searched, so there are two plugins, Spring Tools 3 add-on for Spring Tools 4.39. This one as well as this one. I have already installed this. So what we will do is, once you see you will have this install option. For me, it's since it is already installed, it is disabled. Once you click install, you basically will be seeing something like this, and if you continue, you'll get an option something like this. In your case, all the options will be selected, but we don't need all of them. We just need the Spring ID core. If we do this much, then we'll be actually having that Spring support, Spring XML support available. In this lecture, we will be creating a Maven project in Spring Tool Suite. In our previous lecture, we have downloaded Spring Tool Suite and installed it in our app system. So let's head over to Spring Tool Suite and create a Maven project. So currently I am in Spring Tool Suite. It's open. So let's create a Maven project first. So once we search Maven project, create a new Maven project. We do not require any specific Maven project structure. So normally whenever we are selecting Maven project, this STS gives you an option to select archetype. Basically archetype is structure. So Maven already provides different type of based on the different projects, different type of technologies or different type of nature, the project structure is different. That is basically known as archetype. In our case, we are not interested about any particular archetype, so we'll skip it and we'll go with the default archetype. In the next page, we have to give our group ID and the artifact ID. So group ID is basically our project will part of some group. So whenever we are developing applications for an organization, the organization will have a group, or the project might have some sub projects and all. It will share a root, so that root will be the group ID, and artifact ID is the application name here. So I'm providing group ID as com.codefountain.spring.core and artifact ID as Spring Code tasks. The version is by default selected as 0.0.1 snapshot. So normally by default all project starts with the snapshot version. In our case, the packaging is jar, though it supports jar, POM and Word. Since this is a plain Spring project, we will be selecting jar. This again, we have this name and description. We can, these are optionals. I can actually give name Spring Code task, and I can select a description Spring Code task description. So this is fine, and then at the bottom we have parent project. So normally Maven supports multi-module project. In our case, in that case we'll have a parent project. Under that we'll have different child projects, and they will support parent and all. If you check Spring Boot, then basically we have this parent concept. So Spring Boot provides a parent POM. All our Spring Boot projects will be basically referring to that. In this course we are not dealing with that, so we'll skip this part and then finish. Once we click finish, we can see creating project Spring Code tasks. So this is what we discussed in the last section also. This progress bar normally shows all different type of progresses. So in this case, first it is creating the project and then it build the workspace. So this is a empty project. There is nothing in that. If we, when we see our pom.xml, there is nothing in that POM XML. What all we have selected, only those concepts are there. Group ID, we have selected this, and artifact ID, we have provided Spring Code tasks. Version, we have provided that 0.0.1 snapshot, and Spring Code task name. This is typo. So Spring Code task, and then description Spring Code task description. Now we are going to add couple of more things here. First thing is we will be adding a property. So the property will be Spring version. We will be using Spring 5.1.8.release version, and then we will be adding all our dependencies. So I just press Ctrl M to maximize this window. So dependencies, under dependencies we will add one dependency, then we will have this group ID and artifact ID. The group ID will be org.spring framework. So org.spring framework, and our artifact, in this case one artifact we need is Spring Core, and then the last one is the version. So we are using Spring dot version. Similarly, we need another dependency which is Spring context. So these two will be mainly main versions. If you see the project, it's downloading all the dependencies and versions. Okay, some issue. Let's figure it out, what is the issue. Spring framework, so there is a spelling mistake here. As you were corrected, so this is good to go now. In this case, now we can see all the Maven dependencies got added. So Spring Core is added, Spring Context is added. Also, if you notice, we have additional jar files, Spring Express and Spring Beans. Though we have not mentioned these are actually there in our class path. This is because Maven is doing this for us. As at the start of this course, we discussed that we'll be using Maven to manage the dependencies. So here is Maven is actually playing its role. So we are just providing the required dependencies which we need, but there are transitive dependencies which basically requires in the class path for these dependencies to work. So for example, Spring Core might be requiring the Spring JCL or Spring Beans internally, but Maven is doing that transitive dependency resolution for us. Okay, so let's quickly go over it again. So we have this Maven POM file. So this is project. This is the configuration file where we are actually providing all our dependencies. So we have only two dependencies here, Spring Core and Spring Contest. Notice one thing here is we are not giving the version here. Instead of giving as a placeholder manner, we could actually hard coded the version 5.1.8.release, but we are actually using placeholders all the places. This is a good practice. So normally whenever we have version in our POM file, we should basically extract those in terms of properties, so that in future, let's say tomorrow, if we are upgrading to Spring version 5.2.0, we need not go through all the dependencies and change the version. We can change in only one place, and that will reflect in all the entire POM file. So this is a good coding practice. Now, if we go back to our Maven project structure, there is nothing created here. SRC main Java. So this is for our Java files. Source resources are for the other supporting files. So we'll stop here in this. We'll come back to this again later on. Thank you for watching. In the previous lecture, we have installed Spring Tool Suite, as well as we have created our Maven project in our Spring Tool Suite. In this lecture, we are going to install IntelliJ IDEA. IntelliJ IDEA is another Java IDE. So there are two versions available of IntelliJ IDEA. One is Community Edition and another is Ultimate Edition. Community Edition is freely available for everyone, and Ultimate Edition is not free. There is 1 month trial available for this Ultimate Edition, and then we have to buy. IntelliJ IDEA is also available for Windows, macOS and Linux. So the difference between Community Edition and Ultimate Edition is that Ultimate Edition provides many additional stuffs. For example, in Ultimate Edition, IntelliJ IDEA has full support for Spring. So it's very handy and easy to create different configuration and all those things. In this course, we will be using Community Edition, which is freely available for us to download. In case you would like to try Ultimate Edition, you can download Ultimate Edition, but this is only limited to 1 month. So let's head over to this IntelliJ IDEA website. So IntelliJ IDEA is created by a company called JetBrains. So this is IntelliJ IDEA website. We can go to download page. At the moment, the current version available is 2019.1 and 2019.2 is on the way. So once we click on this download button, it will take us to the download page. As you can see here, we have Ultimate Edition as well as Community Edition. In Ultimate Edition, as I said, there is a free trial available, but it's only for a month. And then we have Community Edition, which is free and open source, so we can download this. Also, we can see we have different versions. One is for Windows, one is for macOS, and one is for Linux. If you are using macOS, you can download this Ultimate Edition macOS version or Community Edition macOS version, as well as we have one version for Linux. So in this case, as I said, we'll be using Community Edition. So whichever version you would like, you can download. For this course, I have already downloaded this Community Edition in my system, and it's already available. You can actually download the .exe version and then just double click. If it is in Windows, double click and install. If it is for Mac OS and Linux, please follow the respective guidelines to install it. I have already installed and it is available in my desktop. So we'll just head over there and then we'll have a look. In the previous lecture, we have downloaded IntelliJ IDEA from JetBrains website and installed it. In this particular lecture, we are going to create a Maven project in IntelliJ IDEA. So I have already installed IntelliJ in my system and it is available here in my desktop. As you can see, I'm using the community edition, IntelliJ IDEA community edition, and it's the as of now this is the latest version. So once IntelliJ IDEA is opened, so we can. So this is the window for IntelliJ IDEA. It is quite similar. The layout is quite similar. So in the left hand side, it is quite similar to Spring Tool Suite. In the left hand side, you have all the project leader information, and in the right hand side, in the big window, you have you can view all your Java files, interfaces, or any other property files. On top, you can actually set your configurations and run your programs, and then you have Maven settings in the right hand side. So let's create a new project here, new Maven project in IntelliJ IDEA. So new project. Again, we will be selecting Maven here. If you have downloaded IntelliJ Ultimate Edition, then probably you can see a few more options here. But since this is a community edition, the options are limited here. We are going to use Maven. In your case, you might need to select the project SDK also. You can actually create a new and head over to your Java installation directory, and it will be taking your project SDK. In my case, I have already set up the Java part, so it's by default taking the project SDK as Java version 12. In this case also, we are not going to select any specific type of archetype. So again, Maven is providing all the list of archetypes here. We are not going to use any archetype. We are going to stick to the default one. So we have selected Maven and then go to next. Here again, we have to use group ID and artifact ID. I'm going to use the same structure. com.codefountain.spring.core, and our project name will be Spring Core Tasks. Here again, I just want to put these hyphens, and this is the project location I have already selected. If you want to switch to some other directory, you can click here and browse to your specific directory. I have selected here and I am just going to finish. So it's saying this directory doesn't exist, and IntelliJ IDEA is going to create it. Fine. And since I have already have one project in my workspace, it is asking whether I want to use this window to open the currently the newly created project, or I want to open in a new window. So in this case, I don't want to open another instance of IntelliJ IDEA, so I'm going to use this window. So once I click this window, it just it's showing us these options. Here it's giving all these options. Maven project needs to be imported. I will enable auto import. So enable auto import option I am selecting. Then again, what we have seen for Spring STS, the structure is almost similar. The model version, group ID, artifact ID, and version is as is. Only thing, the project name and the description is not here. As we discussed earlier, those two are optional. So even if we skip those, no problem. I'll just maximize this window a little bit. If I press the shortcut Alt 1, it will maximize the window. Now, similarly, what we have done for STS, we are going to do the same thing. Only thing here, this particular IntelliJ IDEA, basically, you will have quite good tooling support. It's very easy to type here. IntelliJ IDEA will provide a lot of suggestions based on the context. So if I go properties, in this case I just need this, and then I'm going to select this spring dot version, and I'm going to stick to Spring 5.1.8 release, and then I'm going to select the dependencies, and then dependency. So this is what I was talking about. See, with very less typing, we can actually get all these boilerplate code. We need not type. These all will be prompted by IntelliJ. So in this regard, IntelliJ is better than STS. Let's select org.spring framework, and then we'll be using Spring Core and version. So even if you see, even if Maven it is prompting us the latest version also. See 5.2.0. Milestone 3. We are not going to use that. We are going to stick to 5.1.8 release. What I will do is I'll just use this version what I have done for STS. So let's place the version here. We are using this, and then I'll just copy paste this for Spring context as well. And once I save this POM file, again let's go back and see. So if you go to the external dependencies, if your project setup everything is correct, you can see that Maven dependencies are added as part of our external libraries. So here again we are having Spring AOP 5.1.8, Spring Beans, Spring Context, Core, Expressions, and JCL. So these are the bare minimum stuffs we need in this course. We will not be requiring, hopefully will not be requiring any other dependencies. So that's it. So we have set up our Maven project in IntelliJ IDEA. We'll come back to this later part of this course. Thank you for watching. We are at the end of this module. In this module, we have actually set up our development environment, and then we installed Java, the JDK. We have also installed Spring Tool Suite, and then we have created a Maven project in Spring Tool Suite. Followed to that, we had installed IntelliJ IDEA, and then finally we had created a Maven project in IntelliJ IDEA. Thank you for watching. I'll see you in the next module. Welcome to module 3 of Spring Core series. In this module, we are going to provide a brief overview of Spring Framework. We are going to see the history of Spring, as well as we are going to cover different important concepts behind Spring Core. So Spring overview. What is Spring, or what is Spring Framework? So this is the definition I found in Spring documentation. Spring Framework is a Java platform that provides comprehensive infrastructure support for developing Java applications. Spring handles the infrastructure so you can focus on your application. So there is quite a bit of stuff here. One important part is Spring Framework is a Java platform. So it's a Java based framework. It's on top of Java. And then it is talking about infrastructure support. So this part is extremely critical in terms of Spring. There is many things in terms of infrastructure support which Spring does for us. We will come to that in a moment. And then for developing Java applications. So this is again, as Spring is a Java framework, so definitely it is being used for Java application development. And then Spring handles the infrastructure so that you can focus on your application. This is very true in terms of Spring application development. For application developers, there will be many aspects which a developer needs to take care of. For example, you will have transaction management, you will have messaging infrastructure management, or things like other things like remote API handling. So these are not exactly related to the application. These are the infrastructure which is our application depending on. So these infrastructure at times this infrastructure cause too much of problem. For example, let's say we are handling a transaction, a database transaction. So there are many points that needs to be taken care of. Firstly, the commit, whether the transaction is successfully getting committed or not, or if it needs to be rolled back, or different save points, or different connection management. So these all are actually infrastructure. It has nothing to do with the actual business part of it. So in these scenarios, Spring comes very handy. It does the heavy lifting for us. So for example, if you see, let's say you want to make a Java method execute in a database transaction without having to deal with the transaction API. Or in that matter, let's say you want to make a local method a remote procedure without having to deal with the remote APIs. So these remote API or transaction API, these are the infrastructure here. In terms of Spring framework, Spring provides a very good support in this aspect. So for example, transaction API, Spring has a very robust transaction management facilities. It has that declarative transaction management. So we just tell what we need to do, and Spring takes care most of the infrastructure of the heavy lifting part. In this lecture, we are going to talk about Spring history, how Spring evolved. So the very first version of Spring Framework is Spring Framework 1.0, and it got released in 2004. Following to that, Spring Framework 2.0 came in 2006. In Spring Framework 2006 version, which is 2.0, we have simplified XML configuration and Java 5 support. In the year 2007, Spring Framework 2.5 came, and this 2.5 version provides support for annotation-based configuration. Spring Framework 3.0 came in 2009, and then in 2013 another major release of Spring Framework 4.0 came. In that Java 8 support was added to Spring, and lastly in 2017 Spring Framework 5.0 came. So this is the last major release of Spring, and this is the current version. So in our project, we've seen we are using 5.1.8, and we have some milestone releases like 5.2. But at the moment, Spring Framework 5.0 is the major Spring release. In the last lecture, we have provided an overview for Spring. We discussed what Spring Framework is, and we also discussed how Spring has evolved over the period. Now, in this lecture, we are going to talk about what Spring means in terms of a developer perspective. So it's a dependency injection framework. So at the core of Spring is the dependency injection part, which will come very shortly, and we'll have a detailed section on this. What is dependency injection? But in core, Spring is a dependency injection framework. Spring enable us to build applications from POJOs. So this is also a critical part. The main part of Spring applications are actually lots of POJOs. We'll see what a POJO is. And then Spring also enable us to apply enterprise services non-invasively to the POJOs. So as we have seen in the Spring overview section, that enterprise services means those sort of stuffs where we are dealing with transaction API or messaging API or things like remote API. So those Spring allow us to apply on our POJOs. And last but not the least, Spring is open source. In this lecture, we'll talk about different Spring modules. So this is a reference diagram which I have taken from the Spring's reference documentation. So if we see, we have the test section, we have a core container part, then we have AOP aspects, and then we have data access, integration, and web. So these are the high level blocks in Spring. In the core container, so this is where this is the foundation. So all other modules are actually relying on this core container. And so in core container, we have Spring Beans, which handles all beans, then Spring Core, Spring Context, and Spring Expression Language, which is Spell. So if you have seen when we created the Maven project, we have actually used core and context dependencies, and when we use core dependency, by default Spring Beans automatically came because that was a transitive dependency. So these are actually related. Then we have AOP and aspects. These are for aspect-oriented programming. So Spring provides support for aspect-oriented programming. Then we have instrumentation and messaging. Spring provides excellent support for JMS, messaging infrastructure. It provides many simplified templates and all such things. Then we have web part. In the web part, mainly we have Spring Web, where we have actually Spring MVC, WebSocket, Sublet, and Portlet, all those stuffs. And then we have data access and integration. So Spring provides excellent support for JDBC for Java database connectivity. So your application can actually use different type of templates, JDBC templates, which is provided. Also, Spring provides different type of prepared statement setter, result set, extractor. So those are very handy. Then it has a support for object relational mapping, ORM. Then we have, as I said, we have support for JMS. This is basically for integration purpose. Normally, Spring is used for developing enterprise applications, and enterprise applications will definitely have some integration points so that it can talk to some different applications. And JMS is one of the module which is very heavily used industry wide for communication purpose, message based communication purpose. Then we have OXM, object XML mapping. In Java, so many times we will be using Java and XML. So at times we need to convert Java object to XML structure and XML structure to Java. So this support also is provided. And then last but not the least, there is a support for transaction management. Sometimes managing transactions can be very difficult because there are so many things to take care of. In this regard, Spring provides excellent support for transaction management. It has different type of transaction definitions, different type of transaction managers, like platform transaction manager, data source transaction managers, and so on. Anyway, we are not going to cover all those things in this course. We will stick to the Spring core, so core, context, and beans part, as well as spell. So we're covering the core part of it. So these are the Spring modules in a nutshell. In this lecture, we will talk about object dependency management. A Java application is a collection of objects. So there are hundreds of thousands of objects which form the backbone of the application. Objects interact with each other to achieve application goals. And in order to communicate, objects depend on each other. Let's take one example. So in this case, we have one user service. So this user service is used to perform basic operations. So it provides different services to the user. You can actually create a user, or basically save a user, or find a user, or update a user details, or delete user information. Now this service is provided by user service class, but user service just provide the service. The underlying service or the repository information is different. It can be, the repository could be some relational database, it could be a NoSQL database, it could be an in-memory database, it could be anything. But this user service just takes the repository information, and through this repository it provides these services. So the repository is providing the service, and user service is dependent on user repository. If you see the user repository class here, so here is the actual logic is written. So in this case, some dummy implementation provided, but based on the actual scenario, it could be my relational database where this information can be stored, or it could be anything. But the idea is user service is providing the services with the help of user repository class, and this user repository class could be anything. And so user service is basically dependent on user repository. In order to provide user service to services, it needs a user repository, right? Now one way of managing this dependency, so it would be user service can create the user repository within its own constructor, but this is a very bad idea, because in this there are a couple of problems with it. First problem is this code is not unit test. It could be difficult to do unit testing in this code because we are creating the user repository here itself, and Another problem is user repository creation might not be as simple as it looks like here. There could be, let's say it's a relational database, you might need to pass database information or some other stuff. So user service should not be dealing with all those things. User service just need the dependency of user repository. But in this case, we are actually creating the user repository within user service, which is not at all a good practice. So here is the problem. How do we manage this dependency? How this dependency can be handled in much better way? So here comes the two approaches. One will be handling it through constructor injection. So this injection terms comes into picture, and another option could be setter injection. So basically, user service should never create the user repository class or user repository object within itself. Someone should pass it to it. So one way of passing would be through constructor. So whenever user service is getting created, it ensures or enforces to the user that you pass me a user repository in my constructor. Another way would be user service is asking its user to set the user repository to it. So these are the two ways where we can actually do constructor injection or setter injection. So the term here is dependency injection. So instead of the dependencies, instead of getting it handled inside the actual class, it is being injected from outside. Now how we are injecting, that is done either through constructor injection or setter injection or through some other mechanism. That's a different topic. But the thing is, we are injecting the dependency from outside. That's the reason this term is known as dependency injection. And here comes Spring. So Spring actually helps us to do this dependency injection. So let's see this part as part of demonstration. So we'll just create this piece of code here. So com.codefountain.spring.core, this is our package. In that, let's create this class user service and the Java doc of it provides CRUD support to the users. Okay. And this user service has user repository information with it, private user repository, and let's create this. So once you go to the front of user repository and press Alt Enter, you can see this create class. So I just create this class in the same package, and user repository will have different services. So for example, public void save, and it saves a user. We created this class. This is the POJO for us. It takes the basic user information. Let's create this as well. So user has user ID, and let's say user has its own name. And the toString method. So if I press Alt insert, we will get the shortcut. So I just do a toString, and that's it. And then I just need to have a constructor. There. So we have created the user and user repository. It will just provide a save mechanism. So we are not going to provide any implementation here. So we are just providing the methods. So save method just saves an user in some persistent storage. We don't know here what it is. And public user find by ID. long user ID, and then it just returns. So in this case it just returns null, but in actual scenario it will maybe look up to the database and it will find out that user, or if that user does not exist it should throw some exception. Other case is public void update. So you take updated user and just update it in the database. In this case also we are not providing any implementation. And the last but not the least is the delete. So we delete in existing user, we take the ID of the user and we delete the user or make the user inactive in the database. So these are the services, these are the facilities provided by the user repository class. So it will have it provides an option to save an user, it provides an option to find an user, update an user details, or delete an user information. Now user service just call all, so public void save user and then we will just call user repository dot save and we will just pass the user information. Okay. Similarly, we will have public void find by ID and then we will pass long user ID. So again user repository dot find by ID and supply the user ID, then public void update will take an updated user information and we will just call user repository dot update and we will pass the user information, and the last one is delete, public void delete again takes the long user ID and it calls user repository dot delete, supply the user ID. So the same thing which you have seen in the presentation. So user service has a dependency on this user repository. Okay. So how we create this user repository is the main part here. So in case of Spring provides option to do both constructor injection as well as setter injection. Also Spring provides an option to auto where. So we basically have an auto where option here. So Spring can actually do the auto wearing by type or by name or by constructor. So based on different type of type configured, it can actually find out that user repository and automatically inject it for us. So that is where Spring dependency injection or Spring IOC container comes into play and it helps in dependency management. In the last lecture we talked about dependency management, object dependency management, and how possibly we can deal with it. But there are a couple of problems with those approaches. For example, we talked about when a particular object needs a dependency, someone needs to inject it. And there are, we talked about two different approaches. One is constructor based injection and another is setter based injection. But the problem is, we know we need to inject the object, but the object needs to be created somewhere and it needs to be created by someone. But we don't know who is there someone and where that object needs to be created. And here is the problem. So application developers are responsible to manage the object dependencies and object creation. So though there are approaches, but it is very difficult to create the objects at right place. And another problem is initializing and providing dependencies to child objects can be daunting when there are a large number of them. So an enterprise application actually could be pretty large and there could be hundreds of thousands of objects available, and it can be very difficult to manage the dependency and the object dependency graph by the normal application developers. To deal with this problem, we have Spring IOC container which does this job for us. In the last lecture, we have seen the problem with managing object dependencies by application developers. But what if we just have an option to tell what we need and let Spring inject the dependencies for us? Think about this. So we have seen the constructor injection, or we have seen setter injection. What if the user service class which we have seen just declares that okay, I need user repository, and let someone pass it to it? So Spring IOC container is here to help. We provide Spring container, the IOC container, a bin definitions, and let it manage the object creation, initialization, assembling, and also the dependency graph. So bin definition is something where we actually providing the information about that bin, what all properties or what all dependencies it has, and let Spring manage that bin. So bin definition can be provided through XML bin definition configuration file, or it can be provided through Java configurations. Now let's see how it works. So here is this diagram again from Spring reference documentation. So basically we have Spring container. So this is the Spring inversion of control container, Spring IOC container. What we are giving it is the configuration metadata, and we are providing our POJO or the business objects, right? So in configuration metadata is, we can just think of it's a configuration file or some metadata information which is actually given to the container along with the POJOs, and Spring container reads the metadata information and creates the POJO or the beans in the container. So eventually once the Spring container is successfully initialized, that means it basically read the entire metadata configuration files or the associated dependent metadata files and all those things, and eventually it initializes itself with all the required beans. So the application is fully ready to use all the beans. So far we talked about POJO and beans, right? So what is a POJO? So here is the definition from Wikipedia. A POJO in software engineering, a plain old Java object or POJO is an ordinary Java object and not bounded by any special restriction and not requiring any class path. So the important part here is it's an ordinary Java object and it doesn't require any special restriction. So if we have seen the user object, the user service class, you have seen it just has few methods. That's it, nothing else. It's just a plain Java object. It has some methods and one particular property which was user repository. It doesn't extend anything or things like that. For example, when you say extend part, so for example, if you are writing a class and you want it to declare it as a sublet, then your class should be extending either HTTP sublet or some type of some super type of HTTP sublet, like that, to provide it that sublet nature to it, right? So that the life cycle and all those things are handled. Similarly, if you want to create EJB bin, your class needs to implement that entity bin. But in case of POJO, there is no such thing. You just declare the normal Java class, assign with all the properties or the behaviors. That's it. It is a POJO and it can be handled by Spring. So here is a sample example of a POJO class. Here we have a product. So let's say you are dealing with some e-commerce application and we have various type of products. So product wise, we have each product has a product ID and a product name, and we have the associated getters and setters. That's it. This is a plain old Java object. This is a POJO class. Also, at times we are using the term called bean. So POJOs are also known as beans in terms of Spring context. So when we talk about Spring, in Spring terminology, we use the term bean instead of POJO. We will be calling like bin definition or bin creation and all those things. In this lecture, we'll talk about Spring IOC container. The application context interface represents the Spring IOC container. It is responsible for instantiating, configuring, and assembling the beans. Container gets its instructions on what objects to instantiate, configure, and assemble by reading the configuration metadata. Now, there are two ways we generally pass this configuration metadata. One is the XML bin definition file. So this is an example of XML configuration metadata. So in this case, we have our beans. So different bean information provided here within that beans. Basically, it's the XML document. So it has this XML version and encoding information. And then we have the different namespaces. In this case, since we are using bean from the beans namespace, so that is marked as default. And associated, we have only implemented Spring Beans XSD file here. In this XML file, we are supplying two different bean information. One bean is our person bean, which is, and then we are giving the fully qualified class name, which is in this particular package. Okay, this is one way of feeding this. So if we recall the earlier diagram where we are actually passing this two information, we had this Spring IOC container, and then one way we are supplying the configuration metadata, and other we are supplying the POJO. So if you see this file, the same thing, we are actually supplying our XML configuration file, and we are also supplying our person object. So we are the person class is written somewhere, so just keeping that information here. Right. So these two information, what Spring container does is it just read this information and it loads these beans one after another based on the dependencies. In this case, we have these two are two separate beans. They are not dependent. They are not depending with each other. They don't have any reference. So person is one bean and address is another bean. The other alternative is through Java configuration. So the configuration metadata can be provided through Java configuration as well. So this is a traditional way of passing the Java configuration. So this is the Java configs are mainly to deal with annotations, Java annotations. We have person configuration class. In that we are marking it as add configuration, which makes this class as a Spring Java configuration file. Within that, we are providing all the bean information. So we are giving the bean definitions here. So person object and address object and so on. So this is another way of creating the Spring configuration metadata file. One good thing is slowly Spring is moving from the XML based configuration to Java configuration. Particularly if you see the Spring Boot, it uses the that annotation based configuration a lot, and all mostly new Spring applications are actually starting with this annotation based configuration so that we'll not have to deal with that XML file, a separate file. But there are still projects, old projects, which are actually started with XML files, and it's not very easy for them to move from XML to Java. So most likely both the configurations are going to stay for a while. So in this, we have seen the Java configuration file, just one annotation add configuration that makes this class special, and it makes this class as a Spring configuration file. So Spring will know that okay, this is a configuration file, and in this class I will find bean definitions. So it will look for the bean definitions. So whichever method is marked as with add bean annotation will be the bin. So this is a bin. So what we have seen in the XML structure here, bin ID as person and class equal to this. If you see, the same information is given here. So here if you see, there is no bin ID or things like that provided. The important part here is whatever method name we are providing here will be treated as bin name. Okay, alternatively, this bin annotation has the parameters. So we can actually, if you want to provide a specific name, we can override this behavior, and we can give a person. Let's say you want to give that person some name, and we can actually pass that information in name equal to so and so, and we can actually define. Or let's say we are defining multiple persons, so you can have person so many different overloaded methods. So and we can pass different person names, so that the Spring IOC container will manage those many beans with those different names. In this lecture, we'll provide information about Bean Factory interface. So Bean Factory interface is something which is there in the root of Spring container hierarchy. So in that, Spring dependency injection functionality is implemented using this Bean Factory interface and its sub interfaces such as this application context. Uh, Bean Factory is the root interface for accessing Spring Bean container, and this is also provides basic client view of a Bean container, and this interface is implemented by objects that hold a number of Bean definitions, each uniquely identified by a string name. In this lecture, we will talk about application context interface. So application context is the central interface to provide configuration for a Spring application, and this in particular interface is extremely critical in terms of Spring IOC. So most of the Spring IOC container will be different type of application context. For example, we'll have class path XML application context or annotation configuration application context, and there are different variation of it in terms of web application context. So we have web application context which deals mainly with the web application part. So this application context interface is extremely critical, and this provides a read only when the application is running, but it may be reloaded if the implementation supports this. So this is just an interface, and Spring will Spring provides different implementation of it. Then we have this implements various other interfaces to provide useful features. This interface implements environment capable, message source, and application event publishers. So we'll see what exactly these interfaces does: environment capable, message source, or application event publishers in a later part of this course. In the previous lecture, we have seen Spring IOC container. We have seen how to provide configuration file, metadata configuration file to the IOC container. We have seen there are two ways. One is XML bean definition file and another is Java configuration. In this video lecture, we are going to see XML configuration. So we will create a project. In that we will be creating different POJO, and then we will write the Spring configuration file, the XML file, and then we'll try to access the container. We will then see Java configuration. We'll try to implement the same thing through Java configuration annotations. We'll then try to access the container through Bean Factory interface, and then follow to that, we'll try to access the container through application context. So currently I am in Spring Tool Suite. In our setup module, we have set up Spring Tool Suite and we have created a Maven project. So I have opened that Maven project, and with this we'll be creating a POJO, and then we'll be writing our Spring Bean definition file, and then we'll try to access our bean, that POJO, from a Spring IOC container. So let's get started. I'll create a new package. So com.codefountain dot spring.core, and we'll create a product object, product class here. A product will have an ID, which is let's make it string. We have product ID, and we have product name, and last thing we'll have product description. Okay, we'll generate the constructor. So I did right click source, and then here Spring Tools will provide the option to generate the constructor from fields. I'll use all three of the fields, and I need the getter methods, so that also you can generate. Select getters and this, and the last thing we'll be doing is we'll generate the toString method. So we're using all three of these fields to generate our toString method. Now if we have a look, we have for our product class, in that we have product ID, product name, product description, and we have our constructor and the getter methods to get access to these parameters, and then we have our toString method. Let's save this file. Now we'll create a new Spring Bean definition file. So if you look, you will have Spring here, and you will get Spring Bean configuration file. So with this wizard, we can create our Spring Bean configuration file. Next, so we'll give this a name. We'll use that name application context .xml. Next, now here is a different namespaces. So as of now, these are the namespaces, since we have AOP, beans, C namespace, cache, context, JE, lang, P, task, and util. In this case, we are dealing with the beans, so we'll only select the beans namespace, and we will also select the latest namespace XSD file 4.3, and then we'll do next. There is nothing extra to be added, and finish it off. Once this file is created, let's maximize the editor. So this is the empty application context file. Since this is an XML file, we have this XML version encoding, and then the beans namespace information what we have selected. In the previous that wizard, if you would have selected some other mod namespaces such as AOP or lang or P namespaces, those information would have been here. But since we need only bean, we'll just provide. We have just provided only beans namespace. Now let's create our bean. So if you are familiar with XML, you know that XML, any XML document will be wrapped with this root tag. So beans is our root tag, and within that we'll have multiple bean. So first bean will give ID, bean ID equal to product, and then class equal to, so here we can mention that fully qualified class name dot product. Okay, so we have provided our bean ID, and we have provided the class name. Now if you see this product, this is taking through constructor arguments. So let's make the constructor arguments. We can use constructor args. There are two attributes, one is name and one is value. Since in our case we have three parameters, we are passing three. We have product ID, product name, and product description. Product ID, product name, and product description. So we have, let's verify, product ID, product name, and product description. And since these are simple types, we are using the value attribute here. Had it been some other object, we need to use a reference attribute, which we'll be seeing in later part of this course. In reference, we can actually have other bean definition here, and those bean definitions we can actually reference from our constructor arguments. Let's give the product ID some ID, and then give a product name. Let's say it's a laptop, and product description, let's say it's some laptop. Right? So this is where we have actually defined our bean. Now let's access to this bean. We will have a new class which will be our main class. We will give this a name product main. So this will be our main method. Now how do we access this? So as you said, application context, this is just the definition file. We now need to follow a couple of steps. First thing is instantiating the container. First step is instantiate the Spring IOC container. Then next step will be get the bean information Spring IOC, and then use the bean, right? So let's instantiate the container. So there are multiple, we have seen that Spring application context interface, that's the representation of Spring IOC container. But Spring, this application context is an interface. There are multiple implementations, concrete implementations available. So one is class path XML application context. So if you see, this is one of the concrete implementation of application context. So this, as the name suggests, it can actually load the application context configuration files from class path. And if you see the hierarchy, it extends the abstract XML application context, which in turns extends this abstract replaceable config application context, and then they have this abstract replaceable application context, abstract application context. So this is the interface which again calling configurable application context, which in turn extends application context. So this is the hierarchy, and this is the one of the design philosophy of Spring. So they have multiple layer. In each layer you keep on the more you go down, the more specialized the behavior. So in our case, we are going to use class path XML application context. If you see, we have kept our application context file in SRC main resources folder. So this folder is accessible from class path. Let's create the instantiate the Spring IOC container. First thing we'll do is we'll take application context and we'll give it a name application context equal to new class path XML application context, and we'll pass our application context file name application context.xml. So what we did here is we have instantiated, basically this is where we are instantiating the Spring IOC container, and we are passing that our configuration, that Spring bean definition configuration file to the container. So when this line gets executed, Spring basically reads this application context XML file, which is in our case this bean definition file, and it will find that okay, there is one bean called product, and it will read this fully qualified class name, instantiate this class, and set these values through constructor injection, and make this product object ready for us. Now we have got the application context. From application context, we need to get our bean. So application context provides many methods. So if you go to the bin get bin, there are many overloaded methods. One is get bin. You can pass the class type. Get bin, you can pass your bin name. You can pass the required type and some arguments. You can pass get bin, the bin name and the class type, and so on. So in this case, we are going to use the required type bin. So this is the easy one. Okay, let's use the bin name first and see why the earlier one, that class type, is preferable. So we are giving the bin name as product, right? Now the problem with this is the get bin returns an object type. If we pass the bin name here, then it will returning an object. We need to do explicit typecasting to get the particular type. So for example, we know this is a product. So if we see product equal to this, we will be getting a error that it can't type mismatch, cannot convert from object to product. So we have to explicitly cast We have casted it now, right? Now let's just print out this information, product, right? So let's run it. As you can see, it just printed the product information. Product ID is A123, product name equal to laptop, and product description is some laptop, which we have actually provided in our configuration file. So the interesting thing here is there is no new operator here. We are not instantiating the product class here. We just providing the definition in application context.xml, and then we are instantiating our Spring IOC container. So as part of that process, Spring IOC is reading the bean definition, and then we are asking that application Spring IOC container, hey Spring IOC container, just give us that bean. We're just passing the bean name, and then it is applying us the product information or the product particular bean type. Now this is, we are doing explicit typecasting. We don't want to do that. So what we can do is we can actually we can actually pass the class type of it. So product dot class, so that Spring cannot actually figure out, okay, this is a this is a product class type. So accordingly, it will do the casting and all those things, and will return the appropriate type here, and we can print this. So let's execute this. Again, if you see, it's printing the same information properly, no problem. Now you see there was another option where we are actually passing the name and type. So in this case, Spring is providing able to figure out, because you have only one product type. Let's say we have multiple product types, then it will be difficult for Spring to figure out which product type to provide. Let's say in our application context, we are actually duplicating, and we will have two bean definition. One is let's say product 1, and another is product 2. In product 2, let's say we are giving some different reference number, different product ID, and let's say this time it is mobile. So we have two products, product 1 and product 2, and if we try to run our application, it is going to throw some exception. Let's see what exact exception Spring is throwing. So what we are doing here is we are still initialize the application context. So in this time, application Spring IOC container will figure out that, okay, there are two particular bean definition. It will initialize both of these two beans, and then it will try to have those bean definitions in the container. Once we request for that particular bean information, Spring will return. But in this case, there is some problem. Let's execute and see what is the problem. So as expected, there is some error. If you see what is saying, no unique bean definition exception. So this is the exception Spring is throwing, and it is giving a clear message as well. It is saying no qualifying bean of type product available. Expected single matching bean, but found two, product 1 and product 2. So the type, it can't actually figure out which bean to return, product 1 or product 2, because we are just asking give us a product bean, but there are two of them, which one to provide. To resolve that, the other method comes into play. So you can actually pass that, okay, give me the bean product 1, which is a product type, so that Spring can first figure out, okay, product 1, and it knows, okay, this is a product type, so that it can do the proper casting and return us the bean. Now let's say if we execute this now, it should be fine. So we can see that it is printing the product laptop, which was earlier, and let's say we try to access the product 2. So it again printed our mobile, the second product, right? So this way we can actually instantiate the constructor through application class path application context, the IOC container, and then we can get the bean information. Now there is one thing, if you have noticed, we are actually providing the exact names here. So if you see our product class is having the product ID, product name, and product description. The exact same name we are passing here. Let's say I want to give some different name. I want to give description, DESCCRIPTION. So product description. If we try to initialize now, we are going to get exception. So we are getting exception because now there is no mapping. What the error is saying is unsatisfied dependency exception, and it can't create that product because it is now looking for the parameters which is not matching. So it's saying that ambiguous argument values for parameter of type. So it's not, basically it's not able to find a mapping. Now in order to do that, we have one option where we can do it. It is Java annotation. We can actually pass constructor properties, and we can provide our properties in this fashion. So now what we did was, these two parameters are fine, product ID and product name. Only thing, we have changed our product description. So let's copy it from here, whatever we have typed, and let's re-execute it. So this time Spring was able to map properly. It is actually, even though in the bin definition we have given some name, it is actually able to map that product description to product disk. So this is one way where we can use different name in the bin definition file and in different in the constructor parameter. In the previous lecture, we have seen how we have actually written one Spring XML bin definition file, and we had created our POJO, and then we accessed that bin from the Spring RC container. One quick note here, in case you have trouble creating the Spring bin definition file with Spring Tool Suite 4, you can actually head over to Spring site and download Spring Tool Suite 3, and Spring Tool Suite 3 has support for XML bin definition. So you can actually go to Spring Tool Suite 4 website, and then you can head over to this page where they are mentioning support Spring Tool Suite 3. However, they are saying STS3 distributions will be until mid of 2019, and if you click on this page, it will take you to download STS3, and you can download the STS3 version, Windows, Mac, or Linux. However, I would recommend sticking to Spring Tools 4, STS4, because STS4 is the next generation Spring Tool Suite from Spring, and they recommend using this only. Now let's go back to our STS, and in this module we'll be creating the Spring configuration through Java annotations. So we'll be writing our configuration classes, as well as we'll be writing our beans. So let's create a new project. A new package. com.codefountain.spring.core. But this time we'll write Java config. We will create our first POJO. We will create a POJO class called artist. Now artist will have a name, so private string, let's give first name, and then artist will have a last name. What else? That's it. Let's keep this simple, and we are going to create a constructor. And we'll have our toString method. So this is simple. We have this artist class, and we have it's a simple POJO. We have first name and last name. We have the constructor, and then we have the toString method. Now let's create the configuration class. We'll have a configuration class called artist configuration. So at the moment this is just a normal Java class. It has no meaning, but soon we are going to make this class a bit special, and we are going to add configuration annotation. So once we added the configuration annotation, this class become a Spring Java configuration file. So Spring can actually detect this particular configuration class and read the content inside it. So if we, for example, if we say let's create our bin, so public artist, and then artist, so we'll just return new artist, let's say name John Doe. So at the moment this is just normal method. Spring will not be able to detect this because we have not given the bin annotation. So once we have added the bin annotation, so this became Spring bin. Okay, now so this is pretty simple class. We have artist configuration, we just added one annotation add configuration and one bin definition through add bin annotation. Now let's create the main class. So this is our main class. Now here we'll have our main method. Now we are going to do a couple of things. So as you can see, this is not XML configuration file. So class path XML application context is not going to work here, because class path XML application context is, first of all, it's for XML configuration files, and it can only load configuration files from the class path. But in this case we are not dealing with XML and we have Java annotations. So we have a different implementation of application context. As I mentioned previously, application context is the interface, and there are multiple concrete implementations how we are exactly instantiating our Spring IOC container. So in this case, since we are using Java configuration, we have a different implementation of application context. So let's see. We have we'll still be using our application context because this is our root interface in the application context category. So we'll just give application context and new. Here we are going to use annotation config XML context. Annotation config application context. Okay, so annotation config application context, we have to supply the configuration file name so that it has it can actually find out that okay, this is the configuration file and it needs to read it from here, artist configuration, and we supply the class. So that's it. So in this annotation config application context, it can look for artist configuration class and it can detect okay, this is a Java configuration file, and it can actually scan this file and look for the bin definitions and load those bins, and it will be available in the Spring IOC container. Now since we are accessing it through application context, this will be same what we have done earlier, the methods which we have used so far. So let's this time just print that value, application context dot get bin, and we'll just pass the bin name. For example, in our case the bin name will be in artist configuration class, and as the default naming policy is it will be using whatever is the method name we are giving. So in this case it is artist. Let's provide artist and see what happens if we run our. So we got our artist information printed, first name and last name, right? Now let's change this name. Let's say this is artist1. Is there any impact? Yes, there is, because now Spring is not able to locate a bin name artist, because we have the name with which this bin is getting created in Spring container is artist1, and what we are looking for is artist. So there is no matching. But let's say we want to use we don't want to rely on this default naming convention. So what we can do is we can actually pass the name, and let's say we want to give this my artist. Okay, and in this case we are going to access my artist. So we can actually access. Now it doesn't matter whatever method name I give here. Instead of artist1, let's say if we give another artist, it doesn't matter to us because we have given a name and we are always accessing with that particular name. So in all the scenarios we are actually getting the name printed properly. Now let's see one more thing here. So as of now, so far we are accessing the application context here, but we discussed that we have bin factory as well. We can actually access our application context, or we can actually access our Spring IOC container through bin factory as well. So what we will do is we will just comment out this part and try to reference through bin factory. So we'll do as bin factory. Okay, and here we'll pass our bin factory. So all these methods are still available in bin factory, because actually these methods, get bin methods, are actually from bin factory. Since application context extends bin factory, it inherits those those methods. So you see, we can still access the John Doe this information, the artist information. Only thing is, if we go to the bin factory implementation, so this is the root interface. See, as you can see, there is, it's the parent. There is nothing which it is extending. Or if we read the Java doc of it, we can see this bin factory implementation Spring. It prints the root interface for accessing a Spring Bean container, and this is the basic client view of a Bean container. So this is where we have all these get bin methods. You can actually read the documentation for more information. We have various implementation of bin factory, like listable bin factory and hierarchical bin factory. These bin factories is getting used in different contexts. But if we go to the application context here again, so this is this interface is the primary interface, and this is normally referred as the Spring IOC container, because you can see it is actually extending many other interfaces to provide different behavior. If you remember in our earlier discussion, we have mentioned that application context extends environment capable and message source, application event publisher, source pattern resolver. So each of these interfaces actually providing some functionalities which you might like to use in your application. But the main thing in application context is basically it has many actually information. It has all those things. It is actually extending from different interfaces, like environment capabilities. It can give you the environment information, and it can actually have message source. If you see message source, this is basically for resolving messages and all those stuff. We'll be actually seeing this, how we can support this localization and all those things through this. But remember, this application context is a primary interface in terms of Spring IOC container, and it is very much useful. We are now end of this module. In this module, we have covered Spring overview. We have introduced Spring, and we discussed what Spring is and what Spring framework does. We then talked about Spring history. We discussed how Spring evolved, Spring 1.0 to Spring 5.0. We then talked about different Spring modules: web module, data, integration, access, and then Spring core container, aspect, instrument, and test. And then we talked about object dependency management. We provide detailed explanation what is dependency management, particularly object dependency management, and how it can be very tedious task in a large application. And then we also mentioned that how Spring IOC container can help us dealing with this object dependency management. It can inject the dependency for us. And we have also discussed about bin factory and application context. We have discussed that there are two ways through which we can actually initialize that IOC container. We can do it through we can do it through XML application context, as well as we can do it through Java configuration. We then have seen the demonstration of both type of implementation. We have seen how to access application context as well as how to access bin factory. Thank you for watching this module. I'll be seeing you in the next module. Welcome to this module of Spring Core series. In this module, we will be looking in depth in XML-based configuration. But before proceeding further, let's recap what we have done. We have seen so far that Spring Bean configurations can be done through XML-based configuration or through Java-based configuration. We have also seen different type of application contexts, such as class path XML application context and annotation config application context. We have seen that class path XML application context is being used to load that XML configuration file from class path, and then we have seen annotation config application context is being used for loading that Java-based configuration files. In this tutorial, we are going to look into constructor-based XML configuration. So we have already seen how we are actually creating beans through XML-based configuration. In this module, particularly in this video, we will look in depth about how we are creating beans through constructor arguments, and also have a look about different constructor arg attributes. So let's create a project again. Let's create a package again. I will create a new package. So this package will name as com code fountain spring core, then xml config dot constructor. In this we'll have a simple plain of old Java object Pojo, which will be person. So let's say the person has an ID, integer ID, and then person has first name, and also person has a last name. Then let's create the constructor. So constructor using fields. We are using all three of the parameters, ID, first name and last name. We generated the constructor. We will be using generating the getter methods so that we can access those parameters. So generate getters and setters, select getters and generate. And last thing we will be doing is we will be adding our toString method. So this person class is ready. So this is a plain old Java object. It has three parameters, ID, first name and last name, and we have created the constructor and associated getter methods as well as the toString implementation. Now let's create the application context for it. And note that this file name could be anything. Since this is just a Spring Bean configuration file, I just rename it application context. We can rename it to anything. We can even give it person.xml as well. So let's create. I'll just stick to the pattern which I am using. Other again Spring, head over to Spring and then Spring Bean configuration file. In that in resources section we are going to create. So select that file name should be application context hyphen we are using constructor, so I'll just give cons .xml. Then again we'll be selecting only beans namespace, and we'll be also selecting the latest XSD and finish. So this will initialize the this XML file with all the namespaces. And now let's quickly create the bean definition. So we have seen this earlier. We need an ID. Let's say this ID is person, and then we'll be having a class. So class will be it's person class, which is in this package. We'll add the constructor args. So we will have name, and then we'll have the value.
So we are using simple types here, so you can use name value combination. We have three parameters. One is id, first name and last name. So we have already seen this in our earlier lecture. So let's give the person as id 1, value let's give John and Doe. So this is, we are done with our bean creation. It's just simple. We have given that bean as id as person and the fully qualified class name, and then we have given the constructor arguments id, first name and last name, which is there here again, id, first name and last name. Now let's create the person main class so that we can initialize our IOC container. In this, let's have a main method. What we will do here is application context is equal to new class path XML application context. In that we can pass our application context dot constructor. So just copy this name and place it here. So we got the constructor application constructor XML file here. Now do application context dot get bean and we'll pass person dot class, and let's print the person information right way here. Sysout execute it. So you can see the person information is getting printed, first name, last name and id. So we have already seen this far that how we are passing the constructor arguments and all. But there are other things which you can actually pass in the constructor argument. Let's see one thing here. The value is given as a string. Here the value is given as a string, but what id is expecting here is an integer. So Spring is actually doing that implicit conversion for us and trying to provide us here. Let's say here, let me give some wrong value, which is not an integer. If I try to run it, then Spring is going to throw an exception because it can't cast. So it's saying us undependent that unsatisfied dependency expressed through constructor parameter 0 could not convert argument value of type. Basically it will be integer. It can't convert that java.lambda string to required type integer. It got a number format exception. So that means Spring is internally trying to convert that integer type, that string type to integer type. Okay, so this is one point. Another thing is, let's say I don't want to use the name here. So what I can use basically is I can let's duplicate this so that we can keep this. So I just commented out this bean definition, and what I'll do is instead of using the name, we are going to use the indexes. I can actually give index equal to 0, right? So similarly I can use here index equal to 0, index equal to 1 and index equal to 2, right? So I can give that as well. Once since the bean name is same, we need not do any change in our other files. So you can see that still these things are getting printed properly. Person information getting printed properly, ID, first name and last name. Now let's say to verify whether it's really working, let's just give it as a junk index. Let's say I'm giving 10 here, but there is no index for it of 10 in our constructor arguments. So it is going to fail. So as you can see, Spring is throwing an exception. It is saying that there is could not resolve matching constructor. So it's saying that there is some issue. Okay. So this is one thing. Then one more thing we can do is, let's say I don't want to pass the indexes. I can still I can even do something else. So let's comment out this, and instead of passing the indexes, what we will pass is, we will pass the type information, right? So we still keep the bean information intact, only thing we will change here is type. So type will be giving as int, then here this is not integer, so it's a string. So string is a object type, right? It's not a primitive type, so we have to give the fully qualified name. It's java.lang.string. Same thing is for the last name, that is also a string, right? Now let's execute it. So it is able to, Spring is able to still determine what all these parameters are based on the type. So since integer, the first parameter id is an integer, it's an integer, so it's we are giving type as int, other parameters are string types, so we have given as types as string. We have also seen in the other place in the previous video that if you don't want to use the same name what we are passing here, and if you want to use different name in the constructor, we can use that, we can actually use that constructor properties annotation, and we can pass those new name so that it can actually map. Okay, so this is pretty much about constructor injection. So we can actually, as you can see, we can pass the arguments in different ways, right? We can pass the name, we can pass the indexes, we can pass the type. So if you see, basically we have already covered index, name, and type. Reference type we are not doing right away. We will do it in a later video where we will see how basically beans are interacting with each other, or the beans are referencing with each other. So that will be seen in a later video.
In this lecture, we are going to look into setter-based XML configuration. So in our earlier lecture, we have seen constructor-based XML configuration. In this video, we are going to look into setter-based configuration. As you can see in the example, in this we have a bean definition, bean ID, and the corresponding class, and it has a property. So let's head over to Spring Tool Suite and start create a new package. So I'll just create a new package here with this Spring Core task project, and in this time I will rename it as a setter. Let's create one object here, one class here. We will be using a class called let's say artist. Okay, so our artist class, this will be the Pojo, and artist will have their its first name, and artist will have its last name. Since this is setter based injection, we are not going to create a constructor. Instead, we will be providing normal getters and setters. So let's head over to getters and setters, generate these two getters, first name and last name. I have selected all this time instead of selecting only getters, and generate these getters and setters. We will also have the toString method overridden, generate toString, and we have both first name and last name selected. Let's generate it. So this is the Pojo, and we are done with the Pojo. This is artist class. We have first name, last name, and we have the getters and setters and the toString method. Let's write down the configuration file. So this time I will not go from the beginning. I'll just copy this, and I'll just rename it to application context setter. In this, first of all, let's clean up. We don't need all this information. We'll create fresh bean. Rest all part remains same. So we have the XML and then the beans namespaces and the XST. Let's create the new bean. Bean name, bean ID equal to in this case artist, and class equal to, we are going to use the same class name which we just now created, artist dot. Now here is a difference. In the earlier one we have seen we are actually using constructor args because we have a constructor, and these parameters are getting passed as a constructor argument. But in this case we don't have a constructor, we are going to use setter based injection. So in that case, we need to select the property. So property name equal to what and property value. So property name in our case first name and value. So this is a plain type. So it will support value equal to, let's say again give the same name John. And since this we are not, there is nothing inside the property, we can actually close this property tag, self closing tag, and then let's create the last name also. So last name will be John Doe. Note one thing, that both of these are actually normal string type. So sorry, these are normal data types. Property name equal to first name, which is a string, and property name equal to last name, which is also a string. So we can pass these normal value types. But if these are different type of different object or different bean, we can actually provide a reference here. So again, I'm skipping it for now. We'll come back to this in a later video when we'll be seeing the references, how objects are referencing each other for both constructor as well as for properties. So we are basically done here. We have created the bean definition. We have the first name property and last name property, and we have created both or provided both the values. Now let's head over to our let's create a new class called artist main. This is going to be our main class. In that we'll be having our main method. So I'll just copy this, say this from here in the old. It's same, only thing our application context file name is different. Instead of constructor, it is setter, and instead of person, this time it is artist, right? So we just cleaned up. So what we have done is we are again initializing this application context setter file, and then getting that artist class and printing that bin. So let's execute and see what it is providing. So as you can see, it has actually provided the first name and last name. So Spring still is able to figure out what are the properties it actually needs. So for first name, it is the setter for this set first name, and for last name, it is the set last name. And then since we have configured this toString method, basically it is printing that artist information here. So that means this bean is actually getting created inside this particular artist main here in this Spring IOC container, and we are able to access the artist bean. So far we have seen constructor based dependency injection as well as setter based dependency injection. Now with both the approaches, we can actually initialize our objects and we can actually get our beans. But now the question is, which approach shall we use, whether constructor based or setter based dependency injection? Now there is a nice explanation provided in Spring framework reference documentation. I have captured this from there. So what they are saying is, since you can mix constructor based and setter based DI, it is a good rule of thumb to use constructor for mandatory dependencies and setter methods for configuration methods for optional dependencies. Now Spring team, they generally advocates constructor injection, as it lets you implement application components as immutable objects and ensures that required dependencies are not null. So basically you have control how your objects are getting created. You are not letting the users to simply skip some parameters. You are asking them to pass those parameters. Furthermore, constructor injected components are always returned to the client code in a fully initialized state, so that you don't have anything left out, as I said earlier. As a side note, however, a large number of constructor arguments is a bad code smell, as that indicates your class is probably doing too much, and you should consider splitting it into different classes, so that we can still ensure that single responsibility principle. However, one more thing with setter injection is setter injection should primarily only be used for optional dependencies that can be assigned reasonable default values within the class. Otherwise, not null check needs to be performed everywhere in the code wherever we are using dependency. One benefit of setter injection is that setter methods make objects of that class amendable to reconfigure or re-injection later. So for example, whenever we're using JMX mbeans, we can basically get hold of our objects and we can change their parameters through the setter call. So another thing is use the DI style that makes the most sense for particular classes. Sometimes when dealing with third-party classes for which you don't have the source, the choice is made for you. For example, if a third-party class does not expose any setter methods, then constructor injection may be the only available form of DI. So again, based on the choice or situation given, we can select what option is most suitable to us, and we can take the call whether to use constructor-based injection or setter-based injection. In this lecture, we are going to look into the dependency resolution process. So we have seen we are creating the bean definition, and then we are creating the application context or the Spring IOC container, and then getting the bean from it. But what is happening internally? Let's have a look at that. The application context is created and initialized with configuration metadata, which is nothing but that class path application context, where we are supplying the XML file, or in terms of annotation config application context, we are supplying the configuration metadata class. So that with that we are initializing our application context, and it is getting initialized. Now, as part of initialization process, for each of the bean, its dependencies are expressed in form of properties, constructor arguments, or arguments to the static factory method. So far we have seen when we've created that person class, we are actually passing the constructor arguments, person ID, first name and last name. And or in other case, for artist, we are passing those artist class. We actually pass the first name and last name, those properties in sub properties. So far we have not seen the static factory, or this will be seeing later when we'll be doing Java-based configuration, how to configure static factory bean and to get those beans from there. But the idea is the dependencies or the parameters for that particular bean is expressed in terms of these options. Next, each property or constructor argument that is a value type is converted from its specified format to the actual type of that property or constructor argument. We have seen this point earlier, so that we have seen that ID was passed as a string, that ID and value equal to string 1 we have provided, where we had that value given as string, but the actual type in the class of that particular type ID was integer. But Spring was successfully converted that string value to integer, and we have also seen when we change that integer, that particular value in the XML configuration to some random string, it failed, that we got number format exception. So Spring is basically taking care of that part as well as part of Spring bean creation. And then at the end, Spring container validates the configuration of each bean. As and when Spring bean initializes that container, Spring when the container is basically loading all the beans, it validates the bean configuration, and then it just load that bean. So far we have seen normal bean creation. In those cases, for both constructor injection as well as setter based injection, we have created normal bean definition, where bean basically we created the bean through constructor arguments or through properties. But that the difference was in that case we had only used value types. We have not passed any reference type. But that's seldom the case in case of actual and application. So beans will be probably talking to each other, so they will be referencing with each other, so that this is known as bean collaboration. So they reference each other as and when they need. So one typical example is we have taken the person class. In that person Pojo, we had just given ID, first name and last name. But let's say the person has address, but address is not a normal type. It's not a normal type, it's a reference type or it's a class type. So how do we refer that? So in this video, we are going to look into that. So we'll be having a person class. It will be referring to address. And let's see how exactly we do this. So I'm again back to Spring Tool Suite. Here in STS, I'm going to create a new package. So let's give that package name as bean collaboration. What I'll do is in our earlier project, earlier videos, we had created the person object. I am going to refer to that so that we can save some time. So this is our person object in our new package. And let's close all other old stuffs. What we are going to do is, let's create another object first, the address object. I'm sorry, address class. So it's in a typical address will have a private string, let's say unit name, and then private string street, and then we have area, and we have pin, right? So let's here create normal setter, getter setters. So I'm creating the getters and setters here because you'll be anyway. It doesn't matter. You can choose to create a constructor or getter setters. Any type of injections to be fine. So let's create the both getters and setters. So I've created both the getters and setters for all 4 properties, and then last thing I'll be doing is we'll be adding the toString method so that we can actually print this in our console with appropriate values. So our address object is address class is created. So this is again Pojo. We have given the toString method and we have provided those getters and setters, right? Let's have a reference. Let's say in our person class we have this address, right? So private address. So we have added one address, and now let's create the. I just use a shortcut here, Control 1 on the property name, and it allows me to generate the getters and setters. I just want the getter here, so I'll put it here. We have the getter, and let's change that to string again, and let's regenerate it this time along with the address, right? So now the change here is we have one type which is not a simple type. It is a class type, the reference type, and that reference type we are actually supplying here, and also we are doing this dot address equal to address. So we have now a 4th argument added in our constructor, 4th parameter. Now let's create the constructor. Let's create the configuration file. We'll be using this same we'll just copy this and paste it. We'll see bin collaboration 1. In this case now we have to create the other bin. Let's stick to the name configuration which we have used in our earlier videos. So this is the bin we have created, but now there is a 4th constructor argument, which will be the address type. But let's first create the address bin. So bin id equal to address and class equal to, it's the same package, same part. So just let me keep this here for some time. So in address we are using basic getters and setters, and we have these parameters: unit name, street, area, and pin. Let's create those properties. So property name, unit name, value equal to, let's say, unit 67, and same thing for, we have street here. Unit name we have given, we have provided the street, and then the area, and then the pin. So let's say pin is some pin 76931, and area is, let's say, some area. Let's give something ABC. Let's give something 7 by 8, some street, right? So we had created this address class here, and we have this unit name, street, area, and pin. Now the 4th argument was here constructor argument. Constructor arg name is here the address.
But now we can't reference it with value type because it's not a simple value, so we will be using ref. So that's the reference. If you actually come here and do, basically you have for support for these four, which you have last three we have already seen: name, index and type, and value is we have already used. The ref is the last one, so we just refer with this bin address. So that's the reference name for the address bin, right? So we have actually created all of this properly. This is showing some exception. Okay, saying address class is not found. Okay, the package is different. Package is collaboration, so we have to change the package. Since you copied it from the earlier project, the package we kept it as is. We don't want that. So now both the errors are gone because we are referring the correct package. Now what happens when we ask Spring give us this Spring this person bin? Now Spring determines that okay, there is a constructor argument address of address type, but this address object is not initialized. So Spring, when it goes back and first create this address, and now since address is a plain type, there is no reference, so address can be created without any further dependency resolution process. It creates the address and just inject the address here, and then we are getting the final fully constructed person object. Now let's create our main method. So this time again I am going to use person main, and we'll be having our main method. Let's again, this part will be quite similar to what we have done earlier. Let's copy and paste it here. Only thing changes is the application context file name. Okay, so what we have done is we have actually given the definition here in our application context file, application context, this application context bin. Okay, we have incorrectly modified this file, so let's use this. Okay, so instead of using the bin call one, I incorrectly modified that application context constructor, the old file. So but anyway, here we have the correct beans which we are actually looking for. Only thing changes is in our person main we are going to use the bean which currently the application context file name which currently has all these things. Now let's execute this. So we are getting some error. It's saying no qualifying type of bean XML config person. Okay, so again there is some typing issue here. Okay, so it's saying Spring constructor code fountain Spring config XML config constructor. So it's going to the wrong. So here basically we need to go to this. I'll close all of the Java files, and then this is our class person main, and here we have application context constructor.xml, and application context constructor.xml is referring correctly. So let's execute this. Still some issue, no qualifying bean upcome, so it's basically referring to some wrong configuration file again. So application context constructor. Okay, so see, here is the problem. We are trying to get a person which is from the other class, so we don't have this person here. So this is what happens when we just copy paste. We need person of our of which one is here in our package, but directly referring to this package, this one, which is wrong. Now let's execute. So we can see we have our person ID, first name, last name, address, and all those things getting printed properly. We have this unique name and unique information also getting printed properly. So that means actually Spring is finding out the dependency and then injecting it to the person class. So this we have seen with the constructor injection, right? We can do the same thing with the setter based injection. So let's quickly have a look at the setter based injection as well. We'll just rename it as setter 2. And this time I'll make sure we're opening this. So we don't need all these things. We just need the properties. So property, 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 and property here, right? So address class is already having those the properties, so no need to change anything here. Only thing, look here, this is the difference. Instead of passing a constructor argument, we are setting it property name equal to address, and still we are referring as ref equal to address, right? So only thing we have to change here in that person is we can't have this constructor because we are not doing constructor injection. Let's just comment out that constructor part now, and we will be generating our getters and setters. So let's generate the getters and setters. We have generated the getters and setters, and toString is already there, so no more changes. So I just comment out this constructor part because we don't want to use this constructor injection, and we just want to rely only on getters and setters. Anything else we missed? No. So let's go to our person main class and try to run this time. Okay, we got some exception. Okay, so what we did wrong is we are still referring to the application context constructor. We need to use the setter2 because we are using the setter2 file where we have the actual definition now. And person class remains same. Let's try executing again. Okay, so this time we are able to get the data. Sorry for those type configuration issues. So we have person ID equal to 1, first name, last name, and the address information. So with setter based reference also we could achieve the same what we could do through constructor injection. So the idea is again, so now you can think basically you can have a full sort of beans which they can refer to each other. So for example, you have a let's say class which is a configuration class, which basically you will have plain getters and setters, and you will set the values through different mode. So in these cases we are actually hard coding the values. So in cases, some cases you might not hard code, you can basically use Spring expression language to get those values from different places, class path or system level variable or things like that. We don't hard code these values, and you can have those beans, as many beans as you want, and then you can basically link together those beans based on the reference type. So one example I could give is that Hikari recipe configuration. If you have worked on Hikari recipe database configuration file, they have Hikari config, which is a plain getter setter base object. You can basically set all the required parameters in Hikari config, and that Hikari config you can basically supply to Hikari data source. So Hikari data source expects a config, so basically you can use the same way. You can actually create Hikari config and set all the properties, and then you can use Hikari data source, pass that particular Hikari config, and that this is one way, one real life example where people use Hikari recipe database configuration. In the previous lecture, we have seen how beans can refer to each other. So we have seen it's one way where we can actually achieve that object dependencies. Now there could be scenarios where things can go wrong. So one such example is circular dependency. Let's say if we use predominantly constructor based injection, it is possible to create an unresolvable circular dependency scenario. So for example, let's say we have class A which requires an instance of class B through constructor injection. So while creating class A, you need an instance of class B to fully construct the class A. But now let's say class B also requires an instance of class A through constructor injection. So now if we configure beans for class A and B to be injected into each other, the Spring IOC container
will be in trouble now. So because so when it sees that class A requires class B, it will go and try to resolve class B first. So in our earlier example, we have seen like when we have person and address. So Spring IOC container is seeing that okay, person class person who before creating this person bean, I need an address. So it is going to create an address and creating the address and injecting the address to person. In the similar scenario, when class A is detecting that when Spring is creating class A, it is finding okay, I need a class B before I fully construct class A. So it is going to class B, and when it is trying to create class B, it is again checking oh I need an instance of class A. So now there is a cycle which can never be we can't break this cycle because class they are depending on each other. So if we configure beans for class A and B to be injected into each other, the Spring IOC container detects the circular reference at runtime, and it will actually throw a bin currently in creation exception. Let's see this in an example. For example, here we have two beans. One bean is department, which is IO code fountain, and this department class, which is having one reference of employee, and this reference type is EMP. And then we have employee bean, which is basically referring to the department. Let's see what happens if we try to do such thing. Okay, let's create a new package. I will create a new package and name it as COM code fountain Spring Core, and we'll name it as circular dot dependency. Circular dot dependency. In this first will be, let's close everything else. We'll create a class called department. In department there will be a class called reference called private employee EMP, and then so as of now employee class is not created, so we are getting compilation error, and we are going to soon create it. So public department, we will supply employee EMP, and let's set it this dot EMP equal to EMP. So we have created the employee object. Now let's create this class employee. Now I have created the employee as well. So since employee is created, department is this is fine. And similarly, let's in employee class, let's have a dependency of department, private department, and here we'll have public employee. This is the constructor, and it has a reference of department. So department DPT, and then let's set it this dot department equal to department. So far we are able to create these classes. There are department class which is referring to employee, and employee is actually referring to department. Now let's create a new application context. So I'll just name it circular. So we have created circular XML. In this we don't need all these things, so what we'll do is this will be our department first, and the package is COM code fountain circular this dependency and department. So let's give it as a DEPARTMENT department, and it has a constructor arg. It has name as, let's say, GPT, right? In the sorry, this will be employee. It has a reference to employee, and this reference will be EMP, right? And we don't need these two, so just removing these two. Similarly, I'll just create the employee bin. In employee bin we'll have EMP here, and it will refer to employee, and this reference will be for department. It has a reference to department. So what we have done is, so we have created the department. So in department we are giving name as ID as department, and it has a reference to employee. So employee is actually we are referring here, and similarly we have employee class. So we are creating the employee bean. We are given that ID as employee and the fully qualified class name as employee. And employee has a reference to the department. So DEPT, which we have provided here. Now let's try to create the main class. This time I'll rename it as circular main, and okay, so let's create the main method. Okay, first thing first, we need an application context first. Application context equal to new class path XML application context, class path XML application context, and we need to pass our application context file name, application context circular.xml. Right, so we have passed it, and let's try to access one of the bin. Let's say I'm trying to do get bin of department type, department.class. Right, now what we are doing here is we are just doing the same thing what we have done so far. We are creating that Spring IRC container. We are supplying our application context circular.xml, and then we're trying to access the department class. Now if we run this particular file, so we are going to get some sort of exception. So we are getting this bin currently in creation exception. So error creating bin department, requested bin is currently in creation. Is there an unresolved circular reference? So Spring is able to detect that circular reference, and it is reporting an error that bin currently in creation exception. So far we have seen that we can create as many as beans in our XML bin configuration file as you want. So, but there is a problem associated with it. We don't want to put every single bean in our application in one configuration file. So, what we do is we'll be having probably different modules, application modules or application components, and we'll be segregating the components in their respective configuration files, right? But then the beans has a dependency with each other. Now, how are we going to resolve the dependency? So one option is that we segregate all beans into their respective configuration files, a separate metadata configuration file, and then we just import that XML file, that import resource in our dependent bean configuration file. So one example here is, for example, we can actually use, we have parent configuration here, and then we have a child configuration, and then we have sub-child configurations. So every layer we are just in parent configuration, we are only pushing, we are actually putting only those configurations which are common to all of these child configuration files, and so on. So one example, typical example will be in our batch, Spring Batch. If you have worked with Spring Batch, then probably you will know. So in Spring Batch, we have a configuration for each batch. We have a reader and writer and optional processor. So each reader basically reads some data from some source, and then it processes and write into some sort of storage. Now let's say in a typical example we have multiple batch jobs, right? So multiple batch job does multiple activities, and each batch has its own reader and writer. Now each batch probably let's say in this scenario is reading from a database. It is reading from database and writing into the process record into some other table in some database or some medium. Now one thing which would be common for all these batches will be the data source configuration or the transaction configuration, right? So in these cases we don't want to duplicate those information in our respective batch jobs. So let's say the data source example, let's say we're using Hika recipe data source configuration. So probably we might have initialized our Hika recipe configuration, data source configuration, or let's say we are using Spring transaction, we have initialized our transaction manager, all those things. We don't want that information to be duplicated in all our batches, batch A, B, C, because if later on, let's say tomorrow we want to change something, let's say from Hika recipe we want to move to some other database configuration or other data source configuration. We do not want to come back to each of these batch job and then change individually. For example, let's say in a big application, you might have hundreds of batch XML files configured. You don't want to go back and change each of them. Instead, what we could do is we could extract out all these common configuration into a common separate configuration file, which will be actually having only the data source information, as well as, let's say, the transaction information, transaction manager information. And then in each batch they just import this segregated file, the common configuration file, so that later point in time, if we need to do some changes, what we could do is we can only modify in one file, and that will reflect in all the batches. So this is a typically say clean or separate the responsibilities or the configuration is segregated. We do not need to change everything. So this will be this is a pretty handy process. Let's see this in an example. So for example, let's say we have two different beans. One is artist, right? And there is something called instrument. So let's say each artist has some one or more instrument, but we don't know the instrument configuration. We just can refer to the instrument. Then what we could do is we could segregate this instrument configuration into a separate file, separate configuration file, Spring XML file, and then we could actually import this instrument configuration file in our actual the other configuration file. So Spring will ensure that it download, it merges, or it basically will have that bean information available. And when it initialize that Spring IOC container, you will have both artist and instrument bean available in the configure in the IOC container. So this is similarly similar to a Java. So basically we have objects are referring to each other, right? So each let's say you have artist class in one package and instrument class in another package. So when you use instrument in artist class, we need to import that package, right? So similar thing, we are importing the XML file here. Let's see this in code. So we'll create a new package, and we'll have this, we'll name it first as bean reference. So let's name it to bean import. Okay, and let's close all of this stuff. First thing, let's create the instrument. So each instrument has some sort of ID with it, and each instrument has some name. Okay, and let's create getters and setters for it. So we have created the getters and setters, as well as we are going to create the toString method. So this bean, this instrument bean is instrument class is ready. We can have now let's define this in our application context XML file. So in this case, we will create a separate application context file. So we've created application context instrument.xml, and let's create our instrument bean here. So instrument, and it is there, it is available in this particular package. And there are no constructor args, we are using property. So property name equal to ID and value equal to, let's give some name. And instrument name let's give as piano. So this is where our instrument bean is created and it's defined. Now let's create a new class called artist. So artist will have its own name, private string name, and artist, let's say artist has an instrument. Okay, we have misspelled here. And let's say here also we are using getter setters. Okay, and let's use the toString method. So we have created the artist class and it has this instrument dependency. Now let's create another application context with this artist object. So let's open artist. In this case, dot artist, and artist will have our name. So this part will keep as is. We'll give artist, let's say name is John Doe, and property name equal to instrument, whereas now here we have to use reference because we are using reference to instrument. Okay, here it will be artist instrument. One thing we have to do here is we are going to import the resource, which is application context instrument .xml. So it's implemented, and I think we have missed here to provide the class name, which is instrument. Now let's create our main method. Just call it as only main. In this case, let's again initialize the Spring IRC container, Spring application context, equal to new class path XML application context, and let's pass this. So we'll be referring to application context artist.xml, and we'll try to get bin artist dot class. Now let's try to run it. Okay, as you can see, we can actually have artist name and artist instrument information here. So see, we have not given that artist that instrument information, bin information in our this application context XML file. We have just importing it. So Spring is ensuring that okay, the reference instrument is not here in this bin, and it is actually going and looking into that application context instrument.xml, and from here it is actually creating that instrument bin, and then it is actually injecting that to the artist object. So this way we can actually have this separate. Basically you can have not only one, you can have as many imports as you want. As I said in the earlier example, maybe you can have configuration for database, you can configuration for JMS, you can configuration for transactions. So you can actually segregate those as per the logical group you want, and then you can import and the respective places. So in this lecture we are going to talk about inner bin. So a bean element, when put inside a property or constructor argument elements of another bean, that time we define that bean as a inner bean. So if you can see, we have a bean artist. This artist bean is actually having a dependency of instrument. Uh, so instead of referring it here, property name equal to instrument and ref equal to provide the reference, we are just putting the bean here. So this is one way of creating creating a bean. So we are creating the bean here. Note that we have not given any name because this is an inner bean and there is no it is enclosed inside instrument. Let's see this in our code. Okay, so let me create another configuration file. So Spring XML configuration file, I'll just copy application context and I'll name it as inner bean. Let's open this inner bean.xml. Okay, so we have artist here and instrument we are referring as normal instrument. So instead of referring here, what we will do is we will have property tag and we will put the bean definition here. So I'll get the instrument definition from here and we place it like this and we'll just remove the ID. We don't need an ID here, and I'll just do Control Shift F to format it properly. Now we have property name and property instrument, right? Let's try to create this. I'll use the same configuration file here. Only thing I'll do is I'll just reinstantiate this application context part with the new configuration file inner bean, right? And now if I try to run, so you could see that we are able to access the artist information. Name is this, instrument is this, because the bean is actually inside the property file and it is acting as inner bean. So this is the concept of inner bean. So whenever we put one bean inside another bean, the internal bean is known as inner bean. So far we have seen beans with normal types, or we have created beans with a specific reference type. But let's say we need collections, Java collections. We need a list, or we need a set, or we need a property, right? How do we achieve this? So as you can see in the configuration, we can actually do that as well. So we can create a list, we can create a set, we can create a map, and also we can create a reference type as well. So let's see this in code to get a better understanding. So what I'll do is let's create a new package. I'll call this package as our base package and then collections. Okay. And we'll have import. Okay, we'll have collection holder. This is the class name. In this class, what we're going to have is, let's quickly have private list of string my list. So this is a list. Also let's say I want to have a set, so I can have private set of string and I can pass my set. Or let's say I want to even have a map, I can have map of string comma string my map. Okay, and let's have the associated getters and setters. So I'm selecting all three of them and I'm generating the getters and setters for this. So getters and setters are there, right? Now let's say I want to populate my list, my set, or my map. Now let's go create a new configuration file, Spring Bean definition file. So with this I'll just create application context and I'll just tell it name it as collection. So here I am going to remove all of them. Okay. So let's give our bean a name, bean. Then I will give bean ID equal to, let's say, my collection. And what is the class name? Class name will be equal to com dot. Okay, let's copy this package name. So we are giving our fully qualified class name dot, here we will be getting collection holder. Now first let's say populate the list part. So we need to put some list items. So what is the property here? Again it's a property, so let's give property name equal to my list, so it Spring can actually access my list, and then I'm going to put the props. So this is a new item we are going to put in within props. Okay, so props actually is for properties, we will come to that later. We currently, let's populate the list first. So we are having list, and within the list we have the value. So list value, so let's say I'm giving value 1 and another value I'm giving as value 2. Similarly, let's say we have another property, right? So we have another property called my set. In my set I am going to use here as set. So I can actually have set, and then I can provide the set of values. So let's say again set we are just giving 1, 2, 3, or let's give 1, 2 and 1, since it is set, so the last one won't be there. Then let's say the last property we have is property type equal to my map. In my map I'm going to have map information here, and map, since map is a, we have entry, so entry. Now in entry we have two things, one is key, so let's say key is 1, and or let's say let name it as name 1, and let's say we have a value equal to, let's say, value 1, and we use a save closing tag, and we have such few names like name 2, name 3, and value 2, value 3. So basically what we have done is we have created the collection holder class. In that we have defined three properties, one is list, one is set, and one is map. So for each one of them we are actually creating the list here, creating the set here, and creating the map here. So Spring will ensure that okay, there is a list property involved, so Spring will create a new list, put this value and inject that to collection holder. Similarly it will do the same thing for set. It will see that there is a set property, so it will just create that set and then put these values inside that set, and then it will again inject it to collection holder class, and same thing will be done for the my map as well. Now since this so this is just a normal bean, we have this bean information, we have the properties. Only difference is it's not a regular reference or value type, it's just a list type here, it's just a set here, it's just a map here, right? So let's create that main class. So we'll just write collection main, and we are actually going to create this, and application context equal to new class path XML application context, and we'll give application context collection dot XML. Now we are going to do a couple of things. First thing is from application context dot get bean, we're going to get our bean name, which will be collection holder dot class, and then from there we'll get our list, we'll print the list. Similarly, or let's do one thing, instead of accessing it again and again, let's store it somewhere. So collection holder, so we got our collection holder, and here we're going to use that reference. So we got a collection holder dot list, collection holder dot set, and we'll be having collection holder dot map, right? So let's try to print this and see what it is printing. See, we can see that in list it has printed value 1, value 2. We have used a set, so in set, set doesn't support duplicate values, so even though we have given 1 to 1, only 1 is kept. And then it has the map, so we have name, value, pair, name 1, value 1, name 2, value 2, name 3, value 3. Now let's do one more thing. Let's try to get the type. So what type Spring normally creates? Dot Yep, I'm looking for this. Get class dot get name, then this and this. So it will basically tell us what is the default list type Spring usage, what is the default set, and what is the default map Spring usage, right? So let's rerun this again. So you can see by default it is giving list wise using array list, not linked list. For set it's not, it's using linked hash set, and for map it is using linked hash map. So these are the default types Spring is using. Right. Now that's fine. Now let's say we want to have we have passed simple types. Let's say we want to have list of some reference object, right? How do we do that? So let's go back to our collection holder class, and let's add one more list here, list or any collection type we can add, but let's take list. Let's say I want to have player information and my players, right? So player class is not available. Let's create the player class first. So create class player, and let's say in this case the player has just name, private string name, and we just have one constructor. I'll use constructor injection here. So string name, and we'll use this dot name equal to name. So we have player information, player Pojo created. Now go back to our this collection class, and let's create a couple of players. So we'll have bean, this bean ID equal to player 1 and class equal to, so it's then the same package. So let's copy from here, and let's put it back here, and we'll give player. Okay, so player has constructor args will pass, so constructor arg, and player name, yeah, this name is name, and value equal to, let's say, player 1, right? So let's create a couple of them. So I have player 1, player 2, and player 3. Player 2 and player 3, and the name also let's give player 2 and player 3, right? So we have this at the moment. So we have created 3 players and they are ready. So collection holder, let's close these. So I have closed the ones which we are not using. Collection holder here. Now my players, we have to create the getter setters for these. Control 1, I'll create the getter setters from here. Now in our application context here, I can actually have another property name equal to my players, and here I can actually give list, and then basically instead of value I can actually have reference. So here I could have actually the reference, and I can use the reference. Here the tag is, so you can have two actually, reference bean or reference parent. So reference bean is, let's say, player 1, and this will be self closing tag. So reference bean is player 1, then player 2, player 3. So these are the 3 players. Now if I go back to my collection main and then try to grab this, and let's print my players. So list of players will be printed. Let's try to get that. Okay, so you can see that, okay, player 1, player 2, since we have not implemented the toString method, it's coming a bit ugly. So let's implement that information here in toString. We'll just return that, return the player name. So we will use the name. So player, some space, and then the name. So that's what we want to. So now let's rerun it again. Okay. So since it's inside a list, we are getting this double bracket. Okay, so player 1, player 2, player 3, it's printing the player information. Let's say we want to have a property as well, right? Let's say we want to have private properties, right? So we can actually have our properties, property name equal to, okay, we have not defined here. We need to create the getters and setters. So we got the properties here, and we can use the props, and in props, let's see what we have. We have prop. So what is a prop? Let's say my username is user, and let's say we are having database properties. So my username is there, and let's say I have a couple of them. I have password, and I have, let's say, DB connection URL. Let's say some URL, and password is some password, right? So properties also is there. Now let's go back to collection folder, and we have already created the getters and shooters, so we can do a get properties. If I now try to grab that from collection folder dot get properties, let's see what we are getting. So as you can see, we actually are able to get the properties, password, connection URL, and username. So you know now how exactly we can create this Java collection stuffs. So we have here, we can basically create any type. For example, if you see the type here, we can have we have actually so many different types: set, props, map, list, id, name, bean, array. So far we have seen bean, list, map, props, ref, set, val, and all this. So this is pretty much about Java collections. So in next video we'll see how we can actually merge two different collections. In our previous lecture, we have seen managing Java collections. So we have actually created a class, and we created a list, created a set, we created a map, properties, and different reference type. And we have seen how Spring is actually able to understand and automatically injecting the different type of collections. It has actually injected list, it has injected set, map, and all those types. In this particular video, we are going to look into merging different collections. So what do I mean by merging different collections? Different collections means here the collection which the same type of collection which is available in different classes. Okay, so let's say we have a class called details class, and that's an abstract class. There I have a property. There is a Java properties, and I have on email one, and I want that information. Now in my there is a child class which basically extends this parent class. There I have another property, and when I try to get that property in my child class, I want to get this information merged, and I want to get a common property. In the properties, I want to see both the values. So in this case, if you see, we have our details class. We have one properties, and in that we are storing email one and the value. And in our email details class, which is the child class, we have another property which is details. Name is details. In that actually we have property key as email 2 and the email 2 value. Now let's say when I'm trying to access, I want to have both of these two. How I can do that? So this is where this merging part comes into picture, and Spring actually efficiently manages this. Note that we can't merge different types. It can't be possible, like I have a set here in details class and I have a list here in email child class. It's not possible to merge this. Okay, so let's see this in an example. So basically we have this details class which is abstract class, and then it has property, and similarly email details class, it has this same property details. Only thing, the difference here is we are using a property attribute called marge equal to true. So we are actually instructing Spring that when you create this bin, you make sure you have a parent here. So if Spring knows, okay, there is a parent available, so it will go to these details and make sure, like, okay, this parent property and this property needs to be merged, right? Because you have given marge equal to true. So let's write a code. So we'll be creating our details class. We'll be also creating our email details class, and then we'll see. So head over to the Spring Tool Suite. Head over to the Spring Tool Suite, and then let's see how exactly we can create this property merging. So let's say I have a new package com.codefountain.spring.core. Let's say I'll give property dot merge, and let's say we'll have one class called details class. Okay, so this is an abstract class, and here let's say I'm having a property information. So private properties called details, right? And I have one getters and setters for this property. So I've selected the details, generated the property. So I have this details class, and let's say I have another class called email details. This is just a random name, and let's say this class extends this property, extends this details class, and similarly it also has properties details, and its name is it's a private. And same way what we have done for details, we have this getters and setters in the other class as well. So just let's copy paste it from here, and then let's place it into our email details class, right? So these two are done. Let's create this these two bin in our XML configuration. So we'll just say collection merge, right? And let's go to our collection merge XML, and here we need to create these two bin definition. So first bin is details. So package is different. We are actually using property merge dot details. And one thing is we need to let Spring know that it's abstract. So we are going to use abstract equal to true. Right. So we have mentioned that, and then we have our props. So property is, first thing is property name is details, and it's a property props, so you have to use props, and
we will be using the key value pair here. Sorry. So we have prop is there. We have to use the prop and then key. So let's say the key name is here email one, and the value is email at admin at some xyz.com. Right. Similarly, we have another bean called email details. So let's create this bean here. So it's pretty much same. Email details, it is having details, but only thing is there is no abstract here. It's not an abstract class, but it has a parent. So Spring needs to know that it has a parent, so which is details. So parent equal to details, and in props we are going to use marge equal to true. Right. So we have done this. We have created the details bean. We have actually provided the details bean here information, and let's change that property key to email to, and let's say this is a user at xyz.com. Right. So now let's we are going to create our main class. And in that let's run through main method application context equal to new class path XML application context, and then we will be providing our application context hyphen collection and then marge.xml. Right. This is what we have created, application context collection marge.xml, and in that application context dot get bean. So we are going to get that email details bean here, and then from there we are going to get details, right? And let's do a sysout so that we can see what's inside that properties.
So once we execute this,
okay, we got some exception. So it's saying offending resource application context collection marge. So configuration problem, bean name details is already used in these beans. Okay, the problem. The problem is we didn't change the bean name. We can't have same bean name because it's a bean ID. Sorry, bean ID we didn't change. So bean already one ID is unique. So one ID is already created details. So it can't create the other one with the same identifier. Now let's try to run it, and we can see Spring has actually merged. So I had given one email one which was in our parent class in the details class, and email details which is in the child class. But eventually when you get this, Spring has merged these two. Now there are multiple real life examples of this case. So for example, I'll tell one scenario. Let's say you have an application, and your application is basically supporting multiple databases. So for example, your application can run in Oracle, your application can run in MySQL, it can run in PostgreSQL, or you can support some other database type. But now what you want to do is if the databases are different, there can be some SQL queries which probably will be common throughout the application throughout these databases, but there will be some SQL queries which will be basically different in different databases. So one particular query might be Oracle specific, but the same query there is a syntactical change when you execute it in DB2 or MySQL, right? How do you manage those things? So in those cases, actually what we can do is we can have a bean. Let's say common bean. In that common bean, you define the common class, and then let's say you have a map. In that map, you keep a key value. So in the first bean, you have all those common properties, right? And then you have a bean, separate bean for separate database types. Let's say I have Oracle, and Oracle I'll mention the parent equal to the previous one, and then I will just keep providing my other properties which are specific to Oracle. Then let's say I have one for MySQL, and then I will be providing for MySQL. Then when actually we load these things, since that time, let's say I need Oracle, my application is running in Oracle database at the moment. So what will happen is I'll query through, I'll get the Oracle bean. So what will happen is I'll get the Oracle specific queries plus my common set of queries. So this will give us the common set of queries for Oracle. So I'll get Oracle specific queries plus my common set of queries. Similarly, when I'm going to run for MySQL,
in MySQL I'll be getting the queries for MySQL, as well as I'll get the queries for the common script. So that what happens is I need not in our code we need not have that queries hard coded. Okay, something underscore Oracle, something underscore MySQL, something underscore some other database type. So this is one efficient way of managing, because Spring is providing us that option, so we can actually merge and get a common set for different types. So this database is an example. You might have some other type of example as well. We have seen so far that the beans can refer to each other through references, the ref attribute, and we have also seen that Spring ensures that whenever there is a dependent bean, the dependent bean will be created first, and then that dependent bean will be injected to the actual bean object. Actual bean and the actual object is created. But there are times when we want to force the container to load one or more beans before that actual dependent bean is loaded. We want to be explicit. We don't want to just rely on Spring to do it for us. We just want to tell Spring, hey, Spring container, this is why this is the bean I want, but see, this is the these are the following beans which are actually my current bean is depending on. So what we'll do is we'll just pass that with depends on. With that particular clause, Spring IRC just initialize depending beans before creating the actual bean. So this is just explicit instruction to the Spring container that before you initialize the actual Spring bean, you make sure you initialize those other two or four or how many number of dependency you have, right? And another thing is, in the similar way, when Spring destroys your current bean, it will also make sure that it is actually destroying the depending beans first, and then it is destroying the actual bean. So let's see in the code how exactly we do it. So for example, in this case, this is just a simple example. We have a bean called initialize and init bean. So we are just writing initializer. So we want that initializer bean to get loaded first before our this initializer dependent bean gets loaded. So we have created another bean called init dependent, and then in that we are just explicitly telling Spring that my current bean, this init dependent bean, is depending on the init bean. So Spring will make sure that this init bean is getting created first, and then the init dependent bean is getting created. So in this example, what we'll do is we'll write a similar thing. We'll write initializer class, and then we'll just print some information in that, and then we'll be creating the initializer dependent bean, and then we will just let that, okay, we have this dependency. But note one thing here, there is no reference here, but there is explicit dependency between these two beans. For example, let's say my initializer is something where I am initializing my database connections or doing something registering my database driver, which needs to happen before this bean is getting loaded. So in this case, what happens is since there is no reference, Spring probably will not have information that, okay, I need to load that bean first. But for this bean, initializer dependent bean to work, we need this initializer to initialize first. So we are actually providing the depends on init. So that we are telling Spring that though there is no direct references and all those stuff, but for this initializer dependent to work, this bean needs to be created first, and Spring obeys this contract. So let's create this and these two classes and see how it works. So in this case, we are going to create a new package again. We'll give this package a name. I will tell that is dot depends on, right? So I'll close all other stuffs, and we will have this new class called initializer. So what we'll do is, in this case, we are going to do, we will not have anything. We'll just print a static initializer. In that static, we just print that initializer dot class dot get name. So just printing this class name in that, right? And then we'll have another class initializer dependent. So in this class, again, let's say in this class also we are, let's say we're just having a method called print, okay, and in this we are just
printing again this dot get class dot get name, right? So we are just printing this, and this method should not be private, it should be public so that we can access it. Now let's create this configuration file. I'll just again copy paste. I don't want to do from again from the beginning. So here we'll give depen depends on .xml and the hyphen here, right? So if we go to depends on .xml, we need to remove this part. We don't need all these things. So bin, in here I'll give this id, and let's say this is my init bin, and the class I'm going to mention as, okay, let's copy this class, fully qualified class name. Initializer, and there is no property, nothing, so we can simply create it like this, and then we have init dependent. So these two bins we have created. Only thing now we are going to provide that information that depends on, and we'll say it depends on init, right? Now let's go back and create the main method. So we are going to create the main method, and we will be initializing our Spring container. So application context equal to new class path XML application context, and then we'll be using application context depends on .xml, and this will correct it. And then let's say we want to get application context dot get bean, and this is initialize dependent dot class, and then we have a print method here. Now let's run this class and see how exactly it works. Okay, it's saying file not found exceptions. We have done something wrong here. Application context depends on, okay, so depends on, there is a hyphen here. So see, it is actually printing the initializer first and then doing initializer dependent, right? So Spring is actually ensuring that, see, we are only calling our print method, right? We are calling only print, but Spring is actually loading. So this, since we have called the static in that, so in the initializer static, so whenever this class gets loaded by Spring, this static will definitely get invoked. So that's the reason we are able to see this print, this initializer is getting printed. And the similar way, when we are calling our actual initializer dependent class, we are seeing this print. So that is the way we can actually enforce with this depends on. We can be explicit to the Spring IOC container that what all dependent beans we have and we want. And note that we can actually have multiple depends on, so we can actually give a comma separated list here, and Spring will ensure that all of them are actually loaded before our actual depending bean is getting loaded. In this video, we are going to look into lazy initialization. So by default, when Spring load beans, it will be eager initialization. So when we are actually supplying that application context configuration file or the Java configuration file to Spring Spring container, it basically scans each of the beans and try loading each one of them. So Spring by default try to load those as at the time of it initialize that Spring IOC container. But there will be at times where we don't want those Spring beans to be loaded at the time of container initialization. We want then them to be loaded on demand. So it is possible to load the beans on a lazy loading basis. So that Spring will call the load the bean as and when we call or we refer the bean. So how we can do that? There is a property here again, lazy init equal to true. By default, this is not set. So when we provide lazy init equal to true in our bin definition, we are basically giving Spring instruction that okay, we want this particular bin to be lazy loaded, and we don't want this bin to be available.
So we are not going for any code demonstration for this purpose, for this particular demonstration. So we can actually create LAG in it and then see how exactly it's behaving. So far we have seen we are loading only one XML file in the class path XML application context, but we have the provision to load multiple XML files in the same IOC container. So let's have a look how we can do that. So here I have a class called song, and song has two properties, song name and singer, and I have also created the getters and setters for it, as well as the toString method. And then we have one class called album. We have an album name, and then album name has its own getters and setters, and it has its toString method. Then I had gone ahead and created the application context for album. Here we are actually creating the album bean, and we're just keeping it in this Spring Bean definition file. We also have created a song bean. In that we are actually creating this song bean definition. We have given the singer name and then the song name. So we are creating the song bean. Then in our main method, we are actually loading both the XML files together. So if you see in that class path XML application context, it is actually supporting both of these XML files. So basically, if we go to class path XML application context, this particular this particular constructor has a parameter is taking a variable arguments var args. So we can actually pass as many application context file or the Spring Bean definition file we want. So it will take those many application context files and it will load all of them. So in this case, both of these application context files are getting loaded, and then what we are doing, we are actually asking that application context or the Spring IOC container to give that bean to us. So one is song and one is album. So if I execute this, then we should be actually seeing both the song and album information. So as you can see, we can actually verify this. So actually song is getting printed, song information as well as album information. So this is also another example where we can have multiple XML files and we can load all of them in same application context or same Spring IOC container. So far we have seen class path XML application context, and we have seen that all application context files or the Spring Bean definition files we are actually keeping in class path, and class path XML application context is loading those bean definitions, and those beans whichever are defined inside our bean definition file is accessible once that class path XML application context is loaded or the Spring IOC container is initialized. Now here is another type of application context, file system XML application context. So this is also, as the name suggests, XML. So this is capable of loading XML files, but the difference is this is not a class path XML application context. This is file system XML application context. So that means the file system, it is loading the files from file system. So basically you can give any path, whether it's a relative path or absolute path, we can provide a path, and then this XML application context can actually go and go to that particular path and look for that Spring Bean definition file and load the file. So let's see an example of this. So I have taken the previous example. In this, now what we're doing is instead of using class path XML application context, as you can see, we are using file system XML application context. But in this case, we are not supplying on not only the Spring Bean definition file, we are also supplying the complete path, the absolute path. And now we are mentioning that we are actually using file-based file protocol, so that we are giving file colon and then this slashes. Right, so we are actually supplying this bean definition in this application context album.xml. So if we go, we have this file in this location, C drive my courses directory, where I have application context album file. Now if I run this project, run this program. So what we are doing is we are actually, say, in the similar way we are loading the application context, that is Spring IOC container is initialized, and we are trying to get the bean. So in this case, that album dot class. So this is the same bean which we have seen earlier. So it will print the album name. So as we have executed this, and we could see it's actually printing the album information. And similar to class path XML application context, file system XML application context is also capable of handling multiple XML files. So for example, let's say if we use two files, for example, and then the song one which we have written earlier, and let's say we are also trying to get the song dot class as well, right? So what we did is earlier we were loading only one Spring Bean definition file. Now we are loading two Spring Bean definition files, and both the Bean files are actually Bean definition files are actually present here: application context album and application context song. Now if I try to run this project, we should be seeing information for both album and songs. So as you can see, we have this album as well as this song. So we can actually pass, so we can pass multiple files. This also, if we go and have a look at the constructor of file system XML application context, this also takes the takes the variable arguments or varargs, and so we can pass as many number of XML files as you want, and Spring will make sure they are loading one after another. We are now end of this module. In this module, we have covered POJOs and we have configured POJOs through XML Bean definition file, and then we have covered application context. We have also seen constructor and setter based injection. We have seen the different type of injections, constructor injection, where we are actually passing the constructor args. In constructor arguments, we have seen different types, the name, index and type. We have also seen the setter based injection, where we have actually the properties through which we are setting the different properties, as well as the values and reference types. And then we talked about bean collaboration and import. So we have seen how beans are referring to each other in order to work or in order to communicate. Then we have also seen how we can actually refer beans in some other configuration file, and we can import different beans. And then we have also seen collections, how exactly we can create a list, set, map, properties, or a list of strings, list of different reference types. We then talked about inner bean, where actually instead of referring to a particular bean in some other place, we are actually creating the bean inside the property. And then we talked about depends on. We have seen at times we want to be more explicit, and we are providing that explicit information through depends on in the bean definition, and we are highlighting to Spring that what all bean our current bean is depending on. And then lastly, we talked about lazy initialization. We have seen like we can actually instruct Spring not to load the bean at the time of container creation. We can ask the Spring container to load the bean as and when we request for it. Welcome to this module of Spring course series. In this module, we are going to talk about auto wearing. We'll see how Spring beans can be configured automatically by Spring IOC container. So let's understand what is auto wearing. So far we have manually managed the dependencies between the objects, right? So we have seen, we have created our Spring Bean definition files, and we have created different beans, and we have seen all these beans are actually managed by ourselves. So whenever there is a dependency, basically, so we have explicitly passed those dependencies. We have used the reference attribute to pass those dependencies, and it is explicitly managed by the application developer. However, Spring can automatically manage these dependencies for us by inspecting the container, and this process is known as auto wearing. So as that, it's like sort of wearing the beans based on their dependencies, right? Auto wearing can significantly reduce the need to specify properties or constructor arguments. So we have seen whenever we have this particularly this person class and address, so that address is a dependency in person class. We need to whether we use constructor arguments or we use the setter based injection. In both the cases, we need to manually use the ref attribute and provide the bean reference. Now think of a complex scenarios where we have multiple objects, and we we can have multiple dependencies. So each of those we have to do it manually one after another, and that can be pretty cumbersome to do. Now AutoArray can also update a configuration as objects evolve or they grow or they change. So for example, if a new dependency to a class is added, the dependency can be satisfied automatically without a need to modify the configuration. Now we have understood what is AutoArray. Let's try to understand what are the different types of AutoArray modes provided by Spring IOC container. So there are 4 different types of AutoArray available. The first one is no AutoArray at all. So this is the default configuration, and this is what we have seen so far. So bin references must define by reference ref elements. If we have recall the example which we have used earlier, we have actually referred the dependent beans through the ref attribute in the constructor argument or the properties. This is the default configuration. So by default, Spring is not coming into play to do the AutoArray for us. It expects us to provide the appropriate reference, and accordingly Spring will find out the proper dependencies and it will inject. The next type of AutoArray type is by name. So as the name suggests, it is AutoArray by the Spring bean name. So AutoArray by property name. Spring looks for a bean with the same name as the property that needs to be auto-wired. For example, if a bean definition is set to auto-wire by name and it contains a property called master, then that is basically you will have a set master method. Spring looks for a bean definition named master and uses it to set the property. The third type of auto-wiring mode is by type. So it's by that bean type, bean class type. So let's say property, so it lets a property to be auto-wired if exactly one bean of the property type exists in the container. If more than one type exists, this type of auto-wiring is not going to work and the auto-wiring will fail. The last type of auto-wiring mode is by constructor. So it is similar to by type, but this is mainly for constructor. Again, in this case also, if the constructor is having more than one attribute of similar type, this particular auto-wiring is not going to work. Now we have understood what is auto-wiring and the different types of auto-wiring. In this video, we are going to see the demonstration of the auto-wiring types. In this particular video, we are going to look into the first one, which is no auto-wiring at all. So as we have discussed, let's quickly recall. We have auto-wiring, 4 auto-wiring types. One is auto-wiring as no auto-wiring, then auto-wiring by type, then auto-wiring by name, and then the last one is auto-wiring by constructor. So let's head over to Spring Tool Suite. Here I have already created, since this example we have seen earlier, we'll just quickly go through how exactly we are referencing different beans. What we have done is I have created a new package. In that I have created 2 classes. One is address class. So in address we have unit name, street, area, and pin, and respective getters and setter methods, as well as the toString method. Similarly, I have created the person class. In person class I have created the person ID, person name, and here is our reference dependency, which is address. And we have our getters and setters as well as the toString method. Then finally I have created this XML configuration file, which is here. In this, what we have done is we have created the address bean first, and we are passing some normal properties, the unit name, street, and area, and pin code. So this is pretty simple bean definition. And then we have this person class. In the person class, person bean, we are referring to the person class, and we are passing the person ID, person name. And then here we are using the address. So address is a reference type. So we are actually using the ref attribute to call the address bean. This is something which we have seen earlier multiple times in our earlier video courses. In this case, as we see, we are not using any auto-wiring at all. So Spring is just relying on what we have provided. It is not putting its own intelligence anywhere here. It is just seeing, okay, there is a reference of address, and it is looking for this address bean, and with that it is actually injecting it. So in case, in this case, again I have created the main class also. I am just loading this class path XML application context with application context auto-wire no. and then I'm just looking for the person bean and printing it. If I execute this, we will be seeing the person information, so which is here. So we have person ID, person name, and then the address which got injected by Spring, because we have mentioned that reference address to be injected, and we are actually getting that unit information, unit name, street and area, as well as pin code. So this is something which you have seen earlier, so there is nothing new about it. For the sake of completeness, I just demonstrated this.
In the last video, we have seen auto-aware as no, and in that particular example, we are passing that reference by ourselves. In this video, we are going to look into how we can do auto-aware by name. So let's create another package. So I'll take this previous package as reference, and we'll just rename it to auto-aware by name. So the class name, the classes will be same, which is the person class and the address class. So person class, it is as is, we have ID, name and address, and the associated getter setters and the toString method. Similarly for address as well, we have address information, unit name, street, area and pin, and the associated getter setters and toString method. Now let's copy this as well, and here we'll rename it as by name. Okay, so we'll do some change here now. So as of now, we are not using any auto-aware. So Spring has no information that it needs to auto-aware. So basically, that's the reason it's not doing any auto-awaring. We are just passing the address reference by ourselves. Let's do two changes. One is auto-aware. So auto-aware as by name. So this is one thing, and we'll just remove this property, so that we want, since we have actually asking auto-aware by name, so we want Spring to find the address bean and inject it for us, right? So that's the only change we are going to do now. So let's instantiate this our class path XML application context with this XML configuration file name. So let's go to main class, and I'm going to change the previous one with this one. Now if we execute this, we should be seeing the same outcome what we have seen earlier, and here it is. So if you see, we can still verify the person ID is this person ID, name, address. So even though if you look at this particular bin, there is no information about address provided in the person bin. But since it is using auto-aware by name, Spring is actually looking for the address and then injecting it into the person bin. So how it is doing? It is doing by name. So if we go to our class, here we have a property called address, and here we have one bin name address. So there is a match Spring is finding, and then since it is by name, so it is actually injecting this. Let's say we just change it to address 1. We have given the address bin as that address name is address 1, so there is no matching bin. Person has a property of address, but there is no matching bin in our Spring IRC container. So now what will happen in this case? Any case, so Spring is not going to throw any exception. Since it is a setter injection, it will just simply unable to set that address property here, and it will just left it as null. So let's verify this. So if you see, this time address is appearing as null because there is no matching bin found. If we go back to our previous slide, we can see. So here it's clearly mentioned in Spring documentation that Spring looks for a bean with the same name as the property that needs to be auto-aware. So this line is important. Spring looks for a bean with the same name as the property that needs to be auto-aware. In this case, is there is no bean found, Spring is unable to do the auto-aware. If we change this to address, it will definitely be able to do it again. So this time it's coming as proper address. In the previous lecture, we have seen auto-where by name. We have seen how Spring is looking for beans with the property name. If there is a match found, it is auto-wearing. If there is no match found, Spring is not setting it that particular property and leaving it as null. In this particular video, we are going to look into auto-where by type. So we'll again copy this package and we'll make it as by type. So the class information classes will be same: address, class, main, and person. And we'll again take this old Spring configuration file and we'll rename it as by type. So by name, let's go to our by type. So this is our configuration file now, and we will leave everything as is because we want again the same address property to be auto-wired by Spring. So we have this address being anyway available here, and only thing is missing is the address property here. We are not explicitly referencing it. We want Spring to find it for us, but this time we'll not do by name. This time we'll do by type. So we are doing by type, and that's it. So this is the only change when we are using for auto-where by type. And let's go back to our main class and change that XML configuration file. So this time XML configuration file will be by type, application context XML by type. Now if I initialize, if I try to execute it, we should be seeing the same result. So again we can verify we are actually getting the same exact same outcome what we have seen in earlier two auto-where types. As auto-where no also we have seen the same thing, auto-where by name also we have seen the same thing. Now there is a catch. So in case of auto-where by name, if there is no appropriate bean found for that particular property, Spring is leaving that particular property as null. But here, let's say here how it works is Spring will now look for a type. So for example, address type. So it will look for address type bean in the container. But one important consideration here is you have to make sure there is only one type of that bean exist in the container. So let's say if I have two addresses, for some reason I have another address and address 2 is present, right? Now there will be a problem because since we are trying to auto-where by type and there are two addresses found, address 1, address 2, and both the type matches to the address type. Now Spring will not be able to find which address it needs to inject to our person class. So Spring will throw an exception. So let's try it out and check. So as you can see, we are getting no unique bean definition exception. So this exception comes whenever there is more than one type available and Spring is unable to determine which one to pick. So if you see the error message, it's clearly saying our address bean type address expected single matching bean but found two address and address 2. So it's unable to resolve which one it needs to inject. That's the problem with by type. If you are using by type, we have to ensure there is only one type. And one important property here is when you're doing by type, the name on the bean name doesn't matter. I can give address 1, address 2. It doesn't matter. It is going to work because we are doing a lookup for by type. So in this case, the address class type, that is what matters, not the name. We can give any name here, but in case of by name, the bean name should be exactly same as of what we are using in the property name of our actual bean. In the previous video, we have seen auto-where by type. In this particular video, we are going to look into auto-where by constructor. So let's copy one of these packages and then change it to constructor. So we have renamed our package as constructor. We have our address class, we have our person class. We'll do some changes in the person class. We don't want person to be a setter based injection this time. We are going to change it to constructor. So I'll add the constructor using fields and select all of them and generate the constructor. So we have now this time the constructor, no getter setters. Address class remains as is. We are not making any change. Let it be with getter setters only. This time we want to show that constructor based auto wiring. Let's create copy one of the XML file, previous XML file, and change it to constructor. So here is our new XML file. I close the rest of this. We'll make some changes. Instead of property, these will be constructor arguments, and this will be a constructor argument. So we are providing two constructor argument, and the third one is the address one. If we have a look at our constructor class, constructor here in person class, we have address as one of the property, but this property we are not passing. We want Spring to find out and do it for us. Another change will be the class name is now different, package is different, so it's constructor dot person, and similarly it's constructor dot address. As we have changed the package, so we have to make this change, and here we will be using constructor. So that's the only change here. Now if we go back to our main class, here we have to change, instead of by type we have to change as constructor. So now if we execute this and try to see the output, so we can see Spring is able to identify and doing the same thing which it has done in earlier cases, but this time it has done for the constructor. So the constructor argument which we are passing here, constructor argument, Spring is able to find out and injecting it. Let's say, what if we don't have our address bin at all? What will happen? So you could see if there is no address bin, Spring is throwing exception, because the constructor, if we so no qualifying bin of type address available, expected at least one, but which qualifies as auto candidate. So it is giving an explicit message that other bin is not present, so it can't do the auto wiring. Let's put it back. So this we have seen how exactly auto wire by constructor works. In our previous videos, we have seen Spring auto wiring. We have seen how Spring does the auto wiring through different mode. We have first we have seen no auto wiring. We are doing explicit wiring, and then we have seen auto wiring by name. We have seen auto wiring by type, and then lastly we have seen auto wiring by constructor. Though auto wiring looks fine, and it looks that it can do, Spring can do many things for us under the hood. Sometimes auto wiring can be a problem as well. So for example, auto wiring is not supported for primitive types, so integer, double, all those primitive data types can't be auto wired. Second thing is, auto wiring is less exact than explicit wiring. So when we are doing auto wiring, we are actually leaving the control on Spring IOC container to do the right thing for us, but at times it can go wrong as well, and so it's better to do explicit wiring. So in that case, we will have the control on the application developer. We know what exactly we are doing. Third thing is, multiple bin definitions within the container may match the type specified by the setter method of the constructor argument while doing auto wiring. We are now end of this module. In this module, we have seen auto wiring. We have discussed what auto wiring is. We have then seen auto wiring types. We discussed auto wiring by name, by type, and constructor. We had then seen demonstration of each one of them. We have seen firstly the auto wiring by type, and then by name, and then constructor. We had also discussed that if we don't mention any auto wiring, how exactly as an application developer we need to specify the bin references. We then talked about auto wiring drawbacks, what all problems that auto wiring has. So we are end of this module. I'll see you in the next module. Welcome to this module of Spring course series. In this module, we'll talk about Java based configuration. In our previous module, we have discussed how we can configure bean through XML-based configuration. We have seen with the bean tag, and we have configured many beans with different bean properties or constructor arguments. We have done auto-wiring, but all we have done through XML-based configuration. But slowly, XML-based configurations, the usage of XML-based configuration is reducing, and applications are moving towards annotation-based configuration, so that we do not need to maintain different XML files, and we can have 100% Java code. So what all we'll cover in this module? We'll see configuring beans, but this time with Java annotations, not through the XML based configuration. We'll then have a look at component scan annotation, how Spring handles it can scan for the component through add component scan annotation. We'll then have a look at add configuration and add bean annotations. We'll also have a look at add component, add configuration, add service, and add repository annotations. We'll further discuss about constructor and setter based injection, but again with Java based annotation configuration. We'll talk about auto wiring again, and we'll talk about the add depends on annotation. We'll see add primary, add qualifier, add scope, add lazy annotations. So we in our previous module we have not covered bean scope. So in this module we're going to look into Spring that's bean scope as well. We'll then see importing configurations. So in our previous XML video, if you recollect, we have actually importing resources. We have taken that instrument and artist example where we're importing that instrument which is there in a separate bin definition file. So in this case, we'll see how we can actually import configuration when we are actually using Java-based annotations. So this module also will be quite heavy. There are so many things to cover. So let's get started. In this video, we are going to look into Java-based configuration. So previously, we have seen how we can create a Spring Bean definition file, and that acts our configuration or metadata file to the Spring IOC container, and Spring IOC container reads the bean definition provided inside that XML file, and it basically loads the bean as the definitions are provided. Now, in this particular module, we are going to look how we can configure bean definition in a Java file, in a Java-based configuration file instead of XML-based configuration file. So I have opened IntelliJ IDEA. So for Java-based configurations, we'll be using IntelliJ IDEA. So that we'll have exposure to both the IDEs. In the previous module, we have seen how we are using Spring Tool Suite, and then in this module, we are going to see through how we can use IntelliJ IDEA. Now, what we are going to do in this particular video is we will be creating a configuration class. So this will be similar to what we have done in XML based configuration. So the application context XML acts as the a metadata file or the configuration file for when you're using XML based configuration. So and in this case, the configuration class which will be writing Spring configuration class, that will be our metadata file. Within that, we'll have different beans, bean definition. So let's get started. So in this case, what we're going to do is we'll write a simple that plain old Java object Pojo. We'll be writing one product class. In that, we'll have some product ID, product description, and we'll have getter setters and what we have done earlier. And then we'll have a configuration class. That configuration class will be a holder of all our beans. So and then we'll create a new bean. And then we'll be writing our main class. In that main class, we'll be using a different type of XML context, and then try to load the beans and try to access those beans. So let's get started. I have opened IntelliJ IDEA. So we have done a setup of IntelliJ IDEA. We have created a Maven project in our setup video. So we'll just start from there. So just a quick recap. What we have done is we have created this Spring project here, Maven project. In that we have all those definitions, dependencies provided. If we open the POM XML, we can actually verify we have two dependencies, Spring Core and Spring Context. The same dependencies we are using in our earlier module as well. Let's get started. So I'll just create a new package. We'll give this as a name of Java config, and then base. Let's create another class person, or in this case let's take we said product. So product, we'll have private string product ID, and then we'll have private string product description. Let's create the getter setters. And let's create the toString method. So our Pojo is ready. Now let's create the configuration class. So we'll rename it as product configuration. This product configuration class will have this configuration annotation. So once you put the configuration annotation, this is an instruction for Spring that okay, this is a configuration class, and it will have the bean information in it. Now let's create our bean public product, and let's return a new product, or let's create a product first because we are using getter setter. So product equal to new product, and then let's product dot set product ID. Let's say it's A456, and then product dot product set product description as well. Let's say it's a laptop, and then return the product. So if you see, you have created the method, but this method has no meaning at the moment because it's not a bean definition. So to make it a bean definition, we have to make it as a, we have to put this annotation, add bean annotation, which makes it a bean as a bean, right? Now let's create another configure another file, which will be our main method. So main, in that will be actually having our main class. Now one important thing here is we will be using a different application context equal to new annotation config application context, and we'll be passing our product configuration file to it, product configuration dot class, and then we'll try to we'll print our product. That's it. So we have used different type of application context here. In earlier videos, you have seen class path XML application context, which is used to load XML based configuration file from class path. We then also have seen file system XML application context, which actually loads XML based configuration from anywhere in the file system, or from different URLs. In this case, since we are not dealing with any XML file, so there is no XML based application context, we are using annotations here. So we are using annotation config application context. So this particular application context is for loading annotation based application context. So if you see the documentation, it's saying create a annotation config application context deriving bean definitions from the given annotated classes and automatically refreshing the context. So that's the use here. If we execute this one, so it's running, actually doing the build at the moment. We can actually see what it is building. It's trying to run all these things, and at the end it will give us the output. So you can see it's actually able to find out the product information, product ID, product description. Let's say I have I can actually have many more such beans. Let's say I have for example, let's say I have address class, which we have used earlier. In address class, let's say I have private string unit and private string street. Let's keep it simple, we'll keep this only, and then alt insert, we'll use constructor this time, and let's say we have alt insert to string as well, right? So this is there. Only thing we have to do is, in our configuration file, we have to create this new bean public address, and then we can actually return a new address. Let's say unit is unit 87, and next parameter was the street. It will be like let's say some George Street. So that's it. And again we have to make it as a valid Spring Bean, we have to give this annotation. That's it. Now Spring can actually look for this address class and create this address bean for us. If we go back to our main class, and now this time let's say try to get address bean, so we can actually get address dot class. If we again execute this, we can see it will be printing the address information as well. So at the moment it is doing the build, and once the build is done, it will be printing the output. So in this case the output is again address, so address information is printed. So we have seen we can configure as many as beans we want, but the similar way we were doing in the XML configuration file, but in this case we are going to do all these things in our our product configuration file. So we can have this configuration file, give the configuration annotation, and keep adding as many beans as we want. In our earlier video, we have seen how we can actually configure Spring configurations with add configuration annotation, as well as we have seen how we can configure beans with add bean annotation. We have also seen in our earlier module that how we can actually let Spring auto add the beans for us. In this module, this particular video lecture, we are going to have a look at auto add annotation, how we can how Spring can do the auto adding for us, but in this time with add auto add annotation. We will not use any XML configuration. So let's head back to our IntelliJ IDEA. So here I'll create two classes. One will be our user service class, one will be our user repository class. So let's create a new package first. So in this time I'll write AutoWare base. So let's create a class called first user repository. So it's a it's a repository class in traditional Spring repository class, which provides some persistence methods. Let us provide public void save. Just to keep this class simple, I'll not add anything else, and we'll just print one message called saved. So this is basically doing the work. Now let's create another class called user service. In user service, we will have the same method, public void save, and it will be doing it just need user repository class. Okay, and it will be using user repository dot save. So these two classes will be created. So user service is normally a service class, so this class provides some sort of services to its users, and user repository is the backing repository which connects to the underlying repository. It could be any type of persistent storage. So in this case, right now user repository will definitely be null. We don't want user repository to be created by us. We want to auto add it. So we'll do auto add. That's it. So we'll do auto add. So if we use this annotation not at auto add, Spring will ensure that it actually inject while creating this user service. It will find that there is this particular property that needs to be auto add. Now let's create our user configuration. So this is the configuration class, and in this class we are going to create two beans. Our first bean is public user repository class, and it returns a new user repository. Similarly, we are going to create user bean class as well, user service class as well. So these two beans are ready, and let's try to access. So we'll create our main method here. In main method, we will try to access the application context, which will be, again, since we are using annotation, it will be annotation application context. And we are supplying this user configuration dot class. Now we'll ask the application context to provide us the user service bean, and then we will call our save method here, right? So if I try to execute this, we'll be seeing that saved, which we have, which is returned by our user repository class. So user repository save method is returning saved. But now let's revisit what we have done. So we have created our user repository class. This is the basic class which provides the save method. And then we have user service class. User service class is again calling that user repository save method, and we have actually telling that we need this user repository property here in the user service class. Then we have user configuration. User configuration, this is a plain configuration Java configuration file, and we are instantiating these two beans. But note that we know where we are actually passing that user repository to user service in this configuration. So Spring is actually doing it for us, and it's ensuring that we are this user repository is available here in our user service class, so that we once we require here, we can get it. Now if we go to the auto add annotation, so it has one element called required, and by default it's set to true. So that means that this user repository needs to be present in the Spring IRC container. Otherwise Spring will not be able to create user service class, because in order to create the user service class, Spring requires this user repository to be available. So let's by default, as it mandatory that it's required equal to true. So we did not do anything. Just to verify this, let's for time being, let's comment out this bean. So Spring will not be creating any user repository in Spring IRC container. And if we this time, if we try to run it, we should be seeing some exception, and here it is. So if we verify this exception, again it is saying no such bean definition exception, no qualifying bean of type or core Java config of user repository available, because Spring is not able to auto where, so it's throwing an exception. Now we can actually, what we can do in this case is, let's say user repository, this property is optional. If it is available, we will use it. If it is not available, we will not use it. So in this case, what we will do, we can make required equal to false. If we do that, then we have to ensure that we are doing a check. So if we will just write objects dot is null user repository, then basically we will, let's print a message here, and no repository is provided, and we'll just return from here. So this time Spring will not throw in any exception. It will just try to print this message and come out. So since we have made required equal to false, we are just relaxing the condition here. Since user repository is not available, it is not being injected, and it's simply saying in our null check we are checking it, and we are just printing this message and coming out. So if you are marking as required equal to false, you have to make sure that anywhere we are using this object, we are actually doing appropriate null check. Otherwise there can be null pointer exceptions. Now this is one of the cases. Let's say I don't want to do a direct injection like this. You can I want it to be through a setter injection. So alt insert, again we can write a setter method here, and we want the setter method to be auto add. So still Spring can do that. Only thing in this case, we have to uncomment this. So what we have done is, instead of this property to be auto add, we are doing the auto add by the setter method. So we have created a setter method for this user repository class, and we are auto adding this. Now if we have uncommented here as well, so that this bean will be created, and Spring can actually auto add this user repository property because of this auto add annotation is provided in the user repository method. So if we execute this time, we should be seeing the saved again. So we can actually see that there is the saved is again getting printed because it is able to auto add this property. So that's pretty much about this auto airing. So we have verified that we could actually use auto air here as part of the property. We can do auto air as part of auto air setter method. We can even do auto air as part of constructor as well. Okay, so that's one of these use case. Now let's go back and try to do something different. We will do auto air dot. We'll create a new package. Auto air dot collection. Okay, this should be outside. Okay, so we are using auto air dot collection here. Now what we will do is what we have seen here is when there is one property, Spring is injecting those properties, that particular property. But let's say I have a list of the properties, then how we can actually do that? How we will get that list? Is Spring will be able to will Spring be able to auto air those many those list or array property? So let's see that in the next video. In the last video, we have seen how we can auto air a particular property in one of the class, and we also discussed that in case we need a list, any collection, Java collection, how we can how the Spring will be able to auto air those or not. So let's have a look of these in this video. So in this case, what I'll do, I'll just first close all of this. Now let's first create a product. So this will be our product class. Okay, so the idea here is we have list of products. We'll be having this product Pojo, and we'll be creating multiple products. And what you want, we'll be having a product viewer class. In product viewer class, whatever products is there in the container, we want to view all of them. Okay, so let's see how we can achieve this. We have private string product ID, and we have private string product description. So let's keep it simple. I'll just create a constructor. Also, I will create the toString method with all these two. So this is simple Pojo. We have a product ID, product description, and that's it. Now I want to have a product viewer class. In this class, I want to have an array of products, product, and I will say products. What I want to do is public void view products. So this is a simple. Here what we will do is we will we'll go through each product, and we'll just print out the product information. So we are doing this here. Now let's create the configuration class and create couple of products. This is our product configuration class, and here we will be creating couple of products. So first, let's say public product. We will give this as a product 1, and we'll return new product. Let's say product ID is 1 and product description is laptop, and this is going to be a bin, so that Spring can create this bin. And let's say we have few more products. Let's say we have 4 products now, and we have product 2, which is, let's say, bike. ID should be 2 here. And then let's say we have another product called bike. Let's say this is car, and let's say this is simple product called mobile, and this will be product id as 4, this will be product id as 3, this method will be 3, and this method will be 4. So what we have done is we have created four different products: product 1, product 2, product 3, and product 4, and they have their ids and their description. Now what we want is we want to view these products, right? So let's come create our main class. Since main class is common everywhere, I'll just copy these two lines. So in our main class, we'll be creating our main method, and here we don't want these two. So we want our own product configuration, and what we will do is we will get the we don't want to get the product class, we want to get the product viewer class, and then we want to call view products. So if I run this right now, I am going to get exception. Let's check. We got exception here because there is okay, so this exception, there is no product viewer. Okay, so we have not created our product viewer class. We have to create product viewer bean first. So public product viewer, and let's return new product viewer, right? So we created. Even though we run this, probably will not get an exception, but we will not have anything to print. Okay, we got exception because that's this particular product in product viewer, this is empty, right? So we have not auto-wired this so far, so that's the reason we are not there is no product and we are getting null pointer exception here. So let's do a auto-wired first, and let's see how it changes. So as you can see, it is actually printing all the products: product 1, product 2, product 3, and product 4. We didn't do anything. We didn't create the product list here. What we had done is we had in our configuration file, we just created the products: product 1, product 2, product 3, and product 4. And we have created these many products. What Spring has done, since we are actually auto-wiring it, we are auto-wiring the in product viewer class, we are auto-wiring all our products. Spring has actually gone ahead and it is actually finding all those types and putting into this array, and we have access to this array and we are printing this. Now let's say instead of array, this is a list of product. Even if it is a list, Spring will be able to still figure it out. So for list as well, we can see it is providing the list of products, product id, product 1, 2, 3, 4. And in case of set, if it is a set, we have set of products. So it is able to handle set as well. So 1, 2, 3, 4, and it is giving all the products. Now let's say the more interesting, let's say we have a map and we have string comma product. Will this work? Any guess? And in this case, the we can't iterate like that, so we have to take for products dot entry set. And we are going to print our product. Okay, product dot get key, and let's print here itself so that we'll know. right? So let's execute and see what happens. So we are actually getting the product information here. We are actually getting the product key, which is our product 1, product 2, product 3, and product 4, and our actual product information, which is actual product ID and product description combination. Now what happens here is we are actually Spring is actually getting all the products, since it is a since this is a map, it needs a key as well. So what it has done is it has taken those method names, so product 1, 2, 3, 4. If you go back and check our product configuration class, this is the name we have given, product 1, 2, 3, 4, and Spring has actually created those as the maps key. Right, now let's do some changes here. One point is, by default, when Spring is creating this bin, it is actually creating this bin with this particular name. Whatever is the method name, by default with the method name, Spring will be creating this bin. In case of XML based configuration, we provide the ID or name, and accordingly the bin name is assigned. But here the method name will be bin name. If you want to change this, what we can do is there is a parameter here, name. So we can change this. Let's give that appropriate name for now, laptop, and then for this the name is bike. For this the name is car, and for this the name is mobile. So we have renamed our beans names, and now let's execute it again. So once executed, we can see that names have changed. So it is giving laptop, bike, car, and mobile, and it is providing the product information. So in this video, we have seen how we can handle the collection types here. We can auto add collection types as well. We can provide array type. We can provide list, set, or map. So all of these collection types work. In our last video, we have seen that one class can actually declare its properties, and then it can provide that at word annotation for Spring to understand and inject the particular type while the Spring is creating that bin. What we have seen so far is we have one class, and there is one property, and that particular there is only one particular property is present. So for example, if we go back to this previous exercise, where what we have done is we had the users, we have that user repository class, and in user repository we have this and user service class, and we were actually able to auto add this particular property, user repository property. But the catch here is there is only one user repository being created in our user configuration class. What if I have multiple user repository bins? Then how Spring will understand which user repository to inject? So there will be a problem. Let's quickly simulate this in code, and then we'll see how we can solve this. So let's create a new package. We'll just close all of them. Okay, so in this case we are going to use our previous example, vehicle. So we have a class called vehicle, and this is an abstract class. What we're going to do is it will have one abstract method, public abstract drive, right? Okay, this will be having void. So this is, it's having only one method, this abstract class and this abstract method. It has two implementations. One is bike, extends vehicle, and let's do control O and provide implementation of this. We'll just write driving bike, and then let's create another class called car. Car also extends vehicle, and let's provide the implementation of drive method. We'll write driving car. So we have bike and car, and let's create the vehicle configuration.
This is a configuration class, and let's create the beans quickly. So public vehicle bike, and this return new bike. Similarly, let's create the car. So public vehicle car, return new car. Okay, so what we have done is we have created the vehicle configuration class, and we have created our bike bin. We have initialized that, and we have also initialized our car class, right? So these are created. Now let's create a person class. Okay, so a person will have a vehicle, private vehicle, and let's say we are just doing create another method, public void drive vehicle, and in this we'll do vehicle dot drive, right? And here let us do auto void. Okay, and let's quickly create the person class as well here. So at bin public void public person, and we will return new person. Now create the main class. Here we'll have the main method, and we'll have application context equal to new annotation config application context, and here we'll pass our vehicle configuration file, class file dot class, and then application context dot get bin. Here we'll ask for person, and person dot class dot drive vehicle. Now if I try to let's execute and see what we are getting here now. So we are getting this error, which is quite familiar to us now. No unique bin definition exception. So Spring is not able to auto wire that particular vehicle property here in the person class, because there are two. It is looking for one, but it got two, bike and car. So even though the person has a vehicle, it's not able to auto wire, right? Let's see how we can resolve it. So when we have such type of issues, what we can do is we can use at primary annotation. So at primary, what it does is it gives whichever bin is declared as at primary, that will be given preference by Spring. So let's go to this bin and give at primary. Now if we execute, we should be seeing different result. So we see it is giving driving bike. So when there is a conflict which one to pick up, since we have given primary, so the primary is getting preference, and the bike is being selected for injection. Now let's say I want the same thing happen to car. At primary is given to car, and if I execute this time, it will be printing driving car, right? So this is the usage of at primary annotation. It can actually appear to resolve the conflict when we have multiple types present. So in your actual case, real life application as well, we can there will be many cases where we can actually assign at primary annotation to or the bin which we want it to be a primary one, right? So it can be it can happen like we are expecting one particular type to be given priority. For example, let's say you have some configuration which is which you're expecting, but let's say some other configuration also is present. So in that case, there will be a conflict. So we can assign the one which you want to be getting priority. We can assign that with at primary, and that will be selected. In our previous tutorial, we have seen when we have multiple bins of same type, there is a
ambiguity which bean to be injected. So Spring will have trouble finding which bean to provide, right? So in this case, we have seen this case earlier, and we have seen if there are multiple beans of same type present in the Spring IOC container, then Spring throws some exception saying it can't resolve which bean to be injected, and it throws no unique bean definition exception. One way we have seen is to resolve this ambiguity by providing add primary annotation in while we are creating the bean. So earlier we provided add primary annotation in one of these, and when there is a conflict or ambiguity, Spring this add primary annotation determines which bean to be given priority and that particular bean to be injected. Now another way to do this to resolve this ambiguity is with add qualifier annotation. So add qualifier, here we can mention that, okay, in case you have we have multiple vehicles present, we want to give car as a car as priority, so that car bean qualifies to be attached to this person bean. Now if this case, in this case, if we execute, we should be seeing car driving car, because we have given car as a qualifier bean. In this case, we have not added any primary annotation anywhere here in our configuration, so it's normal beans, and we are handling it at our auto where level. Similarly, if I give as bike, I can actually provide this time it will be printing driving bike, right? So it is actually qualifying able to identify which bean to be injected. Now there are two important points. First point is the at primary annotation is always used with at bean annotation. So here we can qualify which bean we want to make as primary bean, and accordingly if there is ambiguity, then Spring will find out which bean to be given priority. Similarly, at qualifier annotation is always used with at auto void. So if there is again some ambiguity, whichever bean is given in the qualifier will be given priority. In this video, we are going to look into how we can load beans from multiple locations. As we have discussed earlier, we are writing our bean definitions in our configuration files. But for an enterprise application, it will be very difficult to put all the bean definitions in one particular configuration file. So there can be multiple configuration files, and the beans can refer to each other across the configuration files. So how can we make this possible? How can we segregate those beans into multiple configuration files and still refer them as and when we require? And this is always a good practice to not to keep all the beans in a common file or a single configuration file. We should split these into the related module, and each module should have its own configuration file or configuration files based on the number of beans we have. If we recall, in our XML configuration, we have done the same thing. We have actually segregated the beans into multiple XML bean definition file, and then we have imported the bean definition file in the file where we have a dependency, right? So the same thing can be done for configuration, Java based configuration as well. In Java based configuration, we can have multiple @configuration annotation based classes which will be keeping our bean definitions. Let's take a small example here which we have taken for our XML bean definition as well. In this case, what we'll have is we'll have a bean called instrument. This instrument bean will be a part of instrument configuration, which will be a separate Java configuration file, and then we'll have a class, another class called artist. The artist will be part of another configuration file called artist configuration. Now artist will have a dependency on instrument. The artist should have a bean. Artist should have an instrument. So since these are part of two different configuration files, how we can actually make these two bean refer as and when required? So how do we refer instrument from artist class? So when we will construct artist class, we will be requiring a reference to the instrument, but instrument is part of some other configuration file. So how do we do this? So let's head over to our IntelliJ and then try to code this and see how we can solve this problem. So basically we have two solutions for this problem. So let's look at them one by one. Here I will create a new package. We'll just give multi dot locations. Okay, let's create the classes quickly. I'll create the instrument class first. We have instrument name, and let's use our constructor first, and let's use our toString method. Okay, so we have created our instrument class. Let's create the instrument configuration. We have created our instrument configuration class as well. So this is the configuration class. I will put add configuration annotation, and let's create instrument bin. So public instrument, and let's return new instrument. Okay, and let's give the instrument a name called piano. So we have created our instrument class, and we have created our instrument configuration. So when we load this particular configuration file, this instrument bin will be available in Spring IOC container. Now let's create our artist class, and artist class will have definitely have a reference to instrument. So we've created the constructor as well as we have created the toString method. Okay, so we have created our artist class. Now let's create the artist configuration. Artist configuration is also a configuration file, so let's create it as a configuration. And now we want to create the artist bin. So public artist, and let's return a new artist. But here is the problem now. If we go to artist class, class enforces instrument to be passed. Artist should have an instrument. Now how do we get that instrument reference? We don't have it here in this file anywhere. So here let's declare private instrument, and this is one way. Now what will be the instrument value? How do we get it? So what we can use is we can use add value annotation, and how it works is we can mention the name which we have given there, instrument, and so we'll come to this expression and all these things later, but this is one way where we can have this instrument available here. So we can now we can pass the instrument. Let's try to run this. So for that we need to create our main class. And let's create application context equal to new class annotation config application context, and application context dot get bin, and we'll be doing artist dot class, and let's print this. So this, since we have implemented toString, so this would print the artist information. First thing you have to do now, the problem here is we have two different configuration files, instrument configuration and artist configuration. So we need to load both of them here. So we'll do artist configuration dot class, and we'll do instrument configuration dot class. Now let's run. So this is trying to do the build and all. So as you can see, it is printing artist information, instrument equal to instrument, and piano. So it got the reference. Okay. Now here like class path XML application context or file system XML application context, annotation config application context also supports multiple locations, so you can pass as many configuration classes as you want, because it takes a variable argument of class type, class of known type. Now there is, as you said, we have another approach to do this thing. The problem here is we don't know how many classes we'll be having, and what are the dependencies. Now in artist configuration we have a better understanding that what other configuration class we are depending on. We know that we are depending on instrument configuration, which is somewhere else. So it will be better if we try to do this in each configuration layer instead of simply loading all the configuration files in our main method. So what we'll do is we'll just remove this, and then what we have done in case of our XML bin definition file is in our artist at that application context we had import resource, and then we have added our instrument configuration file, and Spring ensure that it has imported that bin and initialize it before it actually start configuring the artist bin. Same thing we are going to do here. We will be doing import, and import, what will import? Will import instrument configuration dot class. So now this will ensure that we have one more configuration class which needs to be imported, right? And in our main method we have removed the other file, and we are having only artist configuration. So let's re-execute and see whether we still have the same behavior. So it's currently executing, and as you can see we have this artist instrument as that instrument. So artist got its instrument. Now if we to verify whether it's working, let's just comment out this import and see. So this time it's going to fail because this is, there is no instrument. So Spring is saying that it can't parse this property or field instrument cannot be found on object. So Spring is not able to understand this. So as one last thing before we complete this video, this expression, so this expression is known as spell, Spring expression language, which is being used by as a Spring. So we have a separate module to cover spell, but at the moment since the instrument is not defined anywhere, it's just one value. We don't know what exactly what it stands for, and Spring can't parse it. That's the reason it is throwing the exception. So we have seen how we can import. So it is always advisable to write small configuration files. So we should be creating one configuration file where and put all the beans which are related to that particular configuration file, and then if we have any other configuration, any something which is different and not related, maybe we can consider splitting those configuration files into some small configuration files and then import them as and when they have the dependencies.
So far we have seen how to create a bin. We have seen we can provide a bin definition in a Spring XML configuration file, or we can provide a bin definition in Java-based configuration file. So based on the bin definition, Spring will create the bin in the IOC container and it will be available for our application to use. But there are few questions. When we are creating bins, we don't know how many of those bins are getting created in the container, because we can refer through get bin to a particular object hundreds of times. There is no limit of it. Also, when a bin is getting created, how long that bin will be available in the container. So all such questions are there. So these all are defined based on the bin scope. In Spring there are 6 scope types available. First one is singleton. This is the default one. It scopes a single bin definition to a single object instance for each Spring IOC container. So this is the default one. Whenever we are defining a particular Spring bin, there will be only one object created in the Spring IOC container, and every time we request for that particular object type, the same object will be returned. This is the default behavior in Spring IOC container. Next type is prototype. So this scopes a single bin definition to any number of object instances. So this is per request one bin will be returned. So these two are the one which we will be using in the normal applications, in traditional Spring application. The rest four are related to web-based applications, and those are related to web application context. So the request type, this scopes a single bin definition to the lifecycle of a single HTTP request. That is, each HTTP request has its own instance of a bin created off the back of a single bin definition, only valid in the context of a web-aware Spring application context. The next scope is session. It scopes a single bin definition to the lifecycle of an HTTP session, only valid in the context of a web-aware Spring application context. Application, it scopes a Spring bin definition to the lifecycle of a sublet context, only valid in the context of a web-aware application context. And the last one is WebSocket. It scopes a single bin definition to the lifecycle of a WebSocket. It only valid in the context of a web-aware Spring application context. We are going to look into singleton and prototype ones, and the rest four request, session, application, and WebSocket are not available for the normal application. It is only available in web-based application context. Let's see a demo of it. We'll take our one example. What we have done is we have created a product class, that one which we are using in this application. We have a product ID, product description, and then we have a shopping cart application, shopping cart class. In that shopping cart we have a list of products which are available. So the idea is we are buying products, and those products are stored in a cart. We have a list of products. In that we can add products and we can get our list of products. Then we have this product configuration file. Here we are creating multiple products. We have created laptop, we have created mobile, and then we have our main class. In this we are doing a couple of things. First thing, we are initializing the our Spring IOC container, and then we are creating our cart, so shopping cart 1, and then we are creating a product laptop. We are adding that product to the shopping cart 1, and then we are printing the number of products we have and the products which are actually available in our cart. Then we are looking for another cart, shopping cart 2. We are creating another one product called mobile, and that mobile we are adding it to shopping cart 2. So once we if we execute it now in this current state, we are going to see the following output. We'll be seeing first one product is added, which is laptop, and then the next product will be the mobile. So here is the output. If you see, first product got added and then the second product. Now this is not this behavior is like this because by default this Spring beans a singleton. So what is happening here is, whenever we are actually looking for the shopping cart 1, so Spring actually returning that cart instance to us, and then when next time we are looking for the cart instance, Spring is returning the same cart instance to us. Because of this reason, what is happening, initially we have added the laptop, and then in the same cart we are adding the mobile. So this behavior is fine as the Spring beans are singleton by default, but in our application perspective, this behavior might not be correct, because this cart is user specific. So whenever we are actually let's say user 1 has requested for the cart, and that user 1 has purchased a laptop, so that item is available in user 1's cart. But when user 2 is requesting for a cart, they should be getting a new cart back. They should not be getting the old cart which the user 1 has, because that is user 1's cart. User 2 needs a new cart. So in this case, we don't want a singleton behavior. We want a prototype behavior. In prototype, each time each get bin request would return us a new instance of this cart. So what we'll do is, we will in order to declare this particular cart type as a prototype, we have to go to our cart class, and here we have declared it as scope. As initially the scope was scope annotation was not added. So by default, Spring has considered a singleton. Now we are explicitly providing the scope as prototype. Once we provide the scope as prototype, Spring will understand, okay, for each get bean request, we need to return a new instance of this cart object. Now if we execute this class, execute our main class, we are going to see a different result. So here is the result now. So in this case, what is happening is we are getting product. First cart is having product 1, which is laptop, that's fine. And when we the same code, when we are asking for second cart, we are getting cart 2 back. But in this cart now the old item is not there because it's a new instance or a fresh instance. So this instance is not freshly getting initialized and then returned to us. And in this case we are getting we are adding the mobile, and it's only mobile is there is no laptop here. In this video tutorial, we are going to look into depends on annotation. In our XML module, we have seen the depends on usage. So in cases where we have we want to be explicitly define the bean dependencies, we can use depends on. There can be scenarios where we have one particular bean or across the beans there might not be direct dependencies, so we can't use ref or auto arranging and all those stuff, but we want to be explicitly define the depends on, because there might be indirect dependencies. Let's say in your dependent class you are initializing some connection or registering some driver, database driver, so something which the depending class has indirectly dependency. In those cases this depends on we can use. So let's head over to our IntelliJ IDEA and we'll see how exactly we can use this annotation. So here I have created the same set of classes which we have seen in the XML section. We have our init class. So this is the class which we want to initialize first, and then we have this initialization. Here we have another just another bean, another class. In the configuration we have created the initialization bean as well as this init bean, and in the main class we have our annotation config application context, and we are trying to access to initialization. But in the configuration we are actually doing something different. What we are doing here is we are mentioning that depends on. We are mentioning that initialization this bean is depending on init bean. So we want Spring to create this init bean first, and then it should create this initialization. So with this we can control the object creation order. We can instruct Spring explicitly how the dependency is, and this depends on it. Actually, if we go back to this, it actually takes an array. If we go back to this annotation, we can see it takes an array, and the value takes an array. We can actually have pass comma separated. Let's say we have some other type init, and then let's say something process some bean name. So you can just give comma separated bean list, and Spring will make sure all these depending beans are getting initialized first, and then it will initialize the rest of this particular bean. We are now end of this module. In this module we talked about Java-based configuration. We covered add configuration and annotation, and then we talked about auto arraying and auto arraying collection and array types. We then talked about primary and qualifier annotations, and then we talked about managing multiple configuration. Lastly, we talked about bean scope and depends on annotation. Thank you for watching this module. I'll see you in the next module. Welcome to this module of Spring course series. In this module, we'll talk about Spring Beans in depth. In the previous modules, we have seen a couple of things about Spring Bean. In this module, we are particularly going to look into Spring Bean lifecycle callback methods, particularly init method and destroy method. And then we'll be covering post construct and pre-destroy annotation. So those are also as lifecycle callback. Then we'll talk about bean post processor and creating beans with factory methods. So static factory, instance factory, and factory bean. So far we are creating the beans through their constructor or setter methods. So there are ways of creating beans through static factory methods or instance factory methods or Spring Bean factory. Then we'll talk about managing environments with add profile annotation. In add profile annotation, normally we can have different set of beans based on the environment, so that we can have a profile for production, we can have a profile for test environment, and we can have a profile for our development environment. And then we'll talk about Spring Aware interfaces. So we can have our POSOs implementing different Spring Aware interfaces to get information about Spring IOC container. So let's have a look about all of these in this module. In this lecture, we'll talk about Spring Bean lifecycle callbacks. At times, beans need to perform certain initialization tasks before they are fully ready to use. So for example, the beans might need to open a file, allocate some memory, or initializing a database or network connection. So this is the task that might need to be performed before we start using the bean or start calling the different methods inside the bean. And beans also needs to ensure that corresponding destruction tasks are also invoked before the beans are removed from the container. So if a bean has initialized database connection, it has to ensure that that connection should be closed before the bean is removed from the container. So init method and destroy method, these are the two life cycle callback methods which helps us to achieve this thing. So basically, if we use init method and destroy method in our bean annotation, we basically instruct Spring to call these life cycle callback methods and invoke those two methods to achieve the initialization and destruction tasks. So let's head over to IntelliJ IDEA and have a look how this works. First, let's create a package. I will call this package as lifecycle. So I have created this package called lifecycle. So what we're going to do is we'll create a small bean definition called file context. In that we'll have our init method and destroy method, as well as we will have our general method. And then we'll write the configuration for it. We'll invoke the init method and destroy method from our bean definition. And then we'll try to invoke initialize our bean and try to invoke the bean method. So first I'll create the file context class. So file context class is the bean definition. In that I'll have three methods: init method, destroy method, and our normal method. So let's write the first one. So here creating our init method. I'm also creating the destroy method. So file handler is closed, and let's say we'll have our normal read method. So we have basically created our file context. We'll have our init method, destroy method, and read file method. So read file is the main method where we are basically going to read the file, and this init method will basically ensure that file exists and it is the file handlers are initialized, and destroy method will close the file handler. Now let's create the file configuration class. So this will be our configuration class. We'll have add configuration annotation, and let's create our bean definition here. So public file context, and file context here will return our file context. Okay. So here so far we have seen in bean that we can actually provide our bean. If we want to use different name, we can pass the name equal to the new name of the bean. Also, if we go to this bean annotation, it actually provides couple of more things. For example, we'll have init method here, as well as we'll have destroy method here, right? So let's use these two parameters in our bean annotation. So I'll call init method equal to init and destroy method equal to destroy. So we have provided this init method and destroy method definition to our methods. So first one is init method is init and destroy method equal to destroy, which are the methods here as well, init and destroy. Now let's create another class, which will be our main class, where we will try to initialize this bean and use it. So let's create public static void main. I will initialize the container. So annotation config application context equal to new annotation config application context, and then we'll pass our file configuration class here, so that it can load this bean definition. And then let's try to get the bean, so which is file context dot class here, and then let's call the read file method. Now we are only calling the read file method here, and let's run and see what exactly comes out from this execution. So you can see it's printing file handler is initialized and file content is read. So which is basically our init method and the read file method, right? So we can see that even though we are not calling our init method here, Spring is ensuring that as soon as the bean is initialized in the container, this particular init method is invoked, and whatever task or execution statements are given, those are executed inside before that bean is fully ready and it's hand over to the application for its usage. Now one important thing to notice here is Spring didn't call the destroy method, right? So that's the reason we are not seeing any third line which is supposed to come here. File handler is closed, so the destroy method is not closed yet. This is because the Spring has not destroyed the bean, and this bean is still available in the IOC container, right? So until we close this particular application context, this bean will be probably available in the container, and Spring is not calling the destroy method. Now let's try to close the application context and see whether Spring is invoking the destroy method or not. So in this case, what happens is when Spring initialize the annotation config application context or the Spring IOC container, it will basically initialize all the beans which are provided in the file configuration or the configuration classes, and then the init method or the initialization method, whatever is provided, will be invoked, and then we can actually use the bean. But until we call the close this application context, this destroy method will not be invoked. Now since in this case we are explicitly closing the application context, so Spring is going to destroy the bean. So as part of destroy, Spring needs to ensure that it is calling that destroy callback as well. So let's run and see whether Spring is calling the destroy callback as well or not. So I'm re-executing our main class. So in this time we can see that file handler is closed. That means Spring has actually invoked this destroy method. File handler is closed, and it is actually destroying the bean. So this way we have seen how to use our init method and destroy method lifecycle callback methods. So through that we can actually instruct Spring to call certain methods once the bean is initialized or the bean is about to get destroyed from the container. In the last lecture, we have seen how to use init method and destroy method lifecycle callback methods to do some additional initialization and destruction tasks once the Spring container is initializing the bean. In this lecture, we are going to see how the same thing can be achieved with add post construct and add pre-destroy annotations. So let's head over to IntelliJ IDEA. Before we use these two annotations, we have to ensure that we have actually added this JavaX annotation dependency, because these two annotations are in this particular dependency, javax.annotation and javax.annotation API. So make sure we have added this dependency in our POM XML, and Maven is putting this jar in the class path. So once that is ready, we'll make changes in the existing code which we have done in the earlier lecture.